Hello, Zisha. Hi, Mohan Raj, Ambika, Pranav, Tejaswini. Welcome, guys. Welcome, everyone. Hi, Santosh. Good evening. Nice to see all of you back. Hi, Vedika. Good morning. Oh, sorry, good evening. Yeah. So, yes, your captain is here. And now that the result season, the counseling season, everything almost is over, guys, I think on a regular basis, I will try and come to solve some problems. Let's say PNG sir is teaching you, example, Newton's laws or circular motion. So, on a regular basis, let's start having these problem solving classes because then you will get that motivation to complete the classes on time and also get into that habit of problem solving. At the end of the day, you have to do MCQs, right? You have to build that concepts. So let's do that. What say, guys? Yeah. Hi, MD. Hi, Monraj. I'm very good. Thank you so much. Hi, Tejaswini. I'm very good, man. Good evening, Mayank. Good evening. Yeah. So let's get there, guys, because I was also checking your test scores and test attendance and everything. It has dropped drastically. So, I have taken this very seriously. The moment you guys are not attending tests, it's a big, big red mark or a flag. I want everyone to be very serious about the test because I'll tell you one thing. Depending on your test scores, eventually you will automatically be trained for advanced or you'll be asked to continue for mains because obviously if you're not scoring well in mains, then I'm also scared, man, that how can I give you more advanced class or how can I give you more high level classes. So remember, right now all the classes are common, everything is same till almost November, December. But after that, if your test scores are not that great, I'll ask you to focus more on mains, obviously, and boards if you're a fresher. So please be sincere. We check all the test scores, we check your test attendance, we check your quizzes, we check your class attendance, everything. We see that seriousness. We want that in all of you. So make sure that you are attending as much as possible. Even if you watch a replay, also it is fine. So if you miss a class, if you watch a replay, that is also shown to us. Yeah, this student has watched the replay for these many minutes. It shows minutes also. Okay, it's not like, sir, I scrolled till the end, I have watched it. No, it shows us. So please take attendance, tests, scores, assignments, how much you are solving, everything seriously. And I'm going to keep coming over here for problem solving and motivating, pushing you towards those fixed targets. Okay? Ready, guys? Shall we start that relative motion chapter? And are you ready to buckle up in case you had lost focus, in case you had lost your path? Yeah, let's do it, guys. Okay? Hi, Ayan. Good evening. Good evening. All right. Very good. Nice to see that. Say yes, sir. Very good. Okay. So let's begin with this concept of relative motion. See, in the relative motion, there are two simple bifurcations which you can say. One is one dimension, that is straight line. So second is obviously two or three dimensional. If you understand 1D, obviously you can understand 2D, 3D, but the concepts are very similar. Formulas are very similar. Okay. Concepts like rain man questions, boat river questions, aeroplane in wind questions, approaching questions, chasing questions, meeting, collision, after what time will they meet, collide, those kind of questions, maximum separation, minimum separation questions. Okay, or just finding relative time, relative displacement, relative velocity questions. All of them are based on these concepts over here. You'll also see in Newton's laws there comes a concept of pseudo force, which is also going to need sometimes some concepts of relative motion. And obviously, in momentum collisions, work power energy, and rotation, you will definitely need that. Hi, Senthil. Good evening. So it's a very important chapter, but if you see the weightage, it is very low because solo questions are less. It is always mixed with some other chapter. Okay, so that way it is very important. That is the reason why I have come over here because it's there in every single chapter almost. Now, see, when you talk about motion, motion we know is relative. So motion is relative, is always relative. So nothing is at absolute rest or in absolute motion. That is the most important thing. Like I cannot say this table is at rest. Maybe for me it is at rest, but for some other person who is traveling, that table might be moving. I cannot say the bus is moving. Yeah, the bus is moving for me, but if there is a parallel bus moving with that bus, for that bus, this bus will look stationary. So nothing as such absolutely can be termed as rest or in motion. The moon is moving around the sun. Is the sun at rest? No, the sun is moving. It is rotating around the center of the galaxy. Is the center of galaxy at rest? No, it is moving around something else. Is there something in the universe which is fixed, attached to some fabric of space? No, there is no such thing which has been pinned or fixed to the fabric of space. There is nothing like that. Keep in mind, right? So nothing is at rest or in motion. Also, everything depends on the perspective. So I would say it's motion is a relative. So we need a perspective. We always need a perspective or a POV, and that is called as your frame of reference. Frame of reference, and the frame of reference is exactly that observer, or is that observer who will be observing things around him. So maybe this is our Pandu observer, and he will observe everything around him, and everything will be based on his perspective. Another person, another perspective. Another person, another new perspective. So everything depends on the frame of reference, point of view, perspective, observer. All these things are very similar in nature. So this observer will usually be shown like this with these lines. Okay. One line here, one line here, and one line here, because it is three-dimensional. And of course, you can also show a watch, because time will be also relative. One person might start measuring now, another person might start measuring after 5 seconds, another person might be measuring inside the lift. So, time also might be different for different people. So the time and the XYZ axis together will give the complete piece of information for that observer. So where are you? I am at this location, this place, XYZ coordinates at this time. Where are you now? Now at this time I am here. Then where will you be? I'll be at this XYZ at this time. So X, Y, Z and T together gives the complete picture to that observer. Okay, so the three coordinates and the time. So the three coordinates and the time, X coordinate, Y coordinate, Z coordinate and the time. This together, this will be your 4 dimensions, I would say. These 4 dimensions, dimensions means information. Okay, things which tell you what is, where it is, when it is. Yeah. So I'm seeing you after a long time. Yes, me too, and nice to see you guys live too, Sabiran. Yeah, it is in the end, it is always philosophy. Darshan, I just started this. This is the first slide. Okay, whatever you're seeing on this slide is the first slide. Before this was the chapter name. Okay. 4 dimensions together will give you the complete piece of information to this observer. So this is very important. Till this point, absolutely clear, guys? Everybody? Yeah? Everyone? What is the meaning of perspective, observer, frame of reference, and what are these 4 dimensions, and why motion is relative? It is not absolute. It's always based on the person observing everything. Now, let's see how do we exactly calculate this perspective and how we denote it. So first, let's see how do we symbolically write the relative motion, denote it, and then we will see how do we calculate relative motion. Then we'll see the application part. First things first. If I use symbols like this, for example, so it's a representation of relative motion. representation of relative motion. So if I use symbols like this, V1, or let's say A0, or let's say displacement of some champa, or let's say, what is it? Position of, let's say, one particle, okay, RP, like this. So when there is only one subscript, like one this zero or some word like champa or P, pandu, particle, whatever, then it is always understood you are measuring it from something called as the ground frame. So all of these measurements, all of these things are done from the ground frame. This is with respect to the ground frame. With respect to the ground frame or ground perspective, ground frame of reference. Always. When there is one subscript or no subscript at all. So you have to imagine as if our observer is attached to the ground. That means the earth is attached to the ground and he is making the observations standing on the earth. When I say the velocity of a bus is 50 kilometers per hour, it is understood. If you are standing on earth, then you see the bus going at 50. Nobody usually says the speed of the bus is 50 kilometers per hour with respect to the earth. It is understood. Okay, we have that common sense that every time we cannot keep specifying with respect to earth, with respect to earth. Too much respect will happen. Okay, I have to make one national anthem only. So we are like, okay, boss, it is understood. But only when a special thing comes, like with respect to that lift, with respect to the bird, with respect to the moving ship, with respect to the flying object, then we use two subscripts. And then what is the way we write it? Like this. For example, V12, or let's say A, P, C, or let's say S, maybe, 3, I don't know, I can use some other symbol. Okay. When I use two subscripts, then it is relative. So what this means is, this is, velocity of one with respect to. Velocity of one with respect to two. Go in the same order. This is, A means acceleration. Acceleration of P, maybe Pandu or some particle, with respect to C. C is some other point or some object labeled C. This means, S means displacement. So displacement of 3 with respect to basically A. Is this absolutely clear? So in all these scenarios, as you can see, this 2, C, A, all of them are nothing but what? Observers or being observed. Obviously, they are all observers because it is with respect to. So they are all observers. 1, P, 3. The first part is the thing which is being observed. Everybody clear about this? All the second symbols or the frames of references. The first symbols in the subscripts are always the object which has been seen. So I can mark that as well. So 1, P, 3, all of them are the particles under, or the objects under observation. Objects under surveillance or observation. Okay. So you are either taking velocity, acceleration, displacement, etc. By the way, this is a very interesting theory. I don't know whether you know this. Not everything is relative except for motion. I cannot say what is the relative force. Okay, there is no meaning of it. I cannot say what is relative torque. There is no sense in that statement. Okay, not everything is relative. Only certain physical quantities can be relative. Is that absolutely clear? Yeah. Great. Everyone with me? Yeah. Not everything is relative. Only very few things like motion, time, etc. velocity, which is motion, acceleration, which is motion. These things are related, not everything. Okay, perfect. Okay, sir. Now I come to the another interesting thing. Say for example, we have let's say this Pandu over here, this amazing Pandu over here. This Pandu is our observer, and this Pandu sees a champa over here. So this is a beautiful champa, let's say. This is beautiful champa over here. Pandu observes the champa. Pandu observes the champa moving like this. Maybe with some speed, maybe 7 meters per second. 7 meters per second is the relative velocity of champa, with respect to, that means for Pandu. Now think the exact reverse. If champa observes Pandu, what do you think Pandu will be seen doing? If Pandu sees champa going like this with 7 meters per second, then what will Pandu be seen doing for champa? What is the meaning of Pandu? Pandu is some imaginary character, man. Okay, don't ask me what is the meaning of Pandu. It's not a Oxford word. Okay, it's just chumma some character I have taken. Then you'll ask me what is champa meaning. Champa is some name. Reverse, yeah, correct. No, not at rest. Champa will see Pandu moving backwards. Not that Pandu has to walk. See, don't get me wrong. Pandu might be just actually not moving on the ground. Maybe champa is walking. So when champa looks at Pandu, Pandu is seen moving backwards. I'm not saying walking backwards. Don't say, sir, Pandu has to walk now. No, sir. No. Pandu will separate out from champa exactly in the opposite way at 7 meters per second is the relative velocity of Pandu with respect to champa. Exactly opposite. And this is true every single time. Now, I know sometimes it becomes difficult for you to understand because the perceived notion or the perceived motion, I would say, is always with respect to the trees, the surroundings, the buildings, the road, the ground, and all of that. So when you ask somebody, is this Pandu moving or not, you will see that tree is here, boss. Pandu is also there with respect to the tree, boss. Tree is not moving for in general ground. So this person is also not moving. So you generally associate motion with respect to the surroundings. So for a moment, forget everything else vanished. Just visualize perfect black space. Nothing is there. No earth, no trees, no water, no sky, no stars, no buildings, no roads, nothing. Literally nothing. In space, this Pandu sees champa going like this. Nothing for him to, make the references with respect to. Nothing to compare with. So Pandu absolutely seeing champa going this way. Champa will see Pandu going like that. They both can argue, you are moving or I am moving. You are moving, I am not moving. But nobody is right, nobody is wrong. Is that right? Yes, Sharvani, correct. Sharvani. Got it? Everyone with me on this? So, this is not just true for velocities, but also for displacement, for acceleration, for position, everything. If champa accelerates at 7 meters per second square, then Pandu will also accelerate with 7 meters per second square in the opposite direction. If champa moves 7 meters this way, then for champa, Pandu will move 7 meters the other way. It's always equal but opposite. Yeah, I know, MD. There is nothing like actual moving. Sir, but champa is the one who is moving. What do you mean by moving? You are again comparing it with the surroundings with respect to the trees. Just imagine floating in space. Just imagine they're not making any hand movements, leg movements, nothing. They're just floating in space. Pandu is chilling, listening to music. Okay, why this cola very D. Okay, he's listening. Then he suddenly opens his eyes. He sees Champa floating like this. Oh, Champa is moving. Champa was also listening to one song. Champa was also listening to the song, and suddenly she says, Pandu. Oh, Pandu is going like this. Who will you argue is moving? Getting my point? Both of them are moving. Okay, very good. Great. So that brings me to the conclusion that, boss, you know what? If this is velocity of 1 with respect to 2, and if I say this is velocity of 2 with respect to 1, they were equal but opposite. So always I can then say velocity of 2 with respect to 1, or even acceleration of 2 with respect to 1, or even displacement of 2 with respect to 1, or even position of 2 with respect to 1, all of them will be negative of the other one. Velocity of 1 with respect to 2, or acceleration of 1 with respect to 2, or displacement of 1 with respect to 2, or position of 1 with respect to 2. All of them with a negative sign. Why that bar? Because they are vectors. So I'm guessing vectors are not taught completely yet now, but still you have some idea that how is a vector shown with a bar and all of that. That is basic. Okay? In 11th standard you have learned this. Okay, so they are negative of each other. Yeah, it's always equal but opposite. So this is the first formula that we have learned regarding all the quantities of motion: position, displacement, velocity, and acceleration. Everything is negative the moment you interchange the observed and the observer. The observed and the observer, the moment you interchange, they are equal but opposite. It's not Newton's third law. Some of them said Newton's third law. No, this is not Newton's third law. It sounds like Newton's third law, but it is not Newton's third law. Newton's third law is about forces, action, reaction. This is not exactly the same. Okay, so don't confuse the two, and you might apply wrong or think of it, perceive it in a wrong way. Okay, but sir, how do I measure these? How do I measure these? Let's say this or this or this or this or this. Anyone individually, if I have to measure, what is the correct way of doing it? I have a simple suggestion. Say, for example, maybe this is object labeled 1, and this is another object labeled 2, and maybe we introduce another third thing over here, and that third thing could be your ground or third other person or some new thing: bus, car, rocket, lift, particle, bird, anything. So maybe this is the third thing. Right now, for simplicity, I will put ground. Later on, we will change this. Right now, I'll just put ground. Say, for example, from the ground perspective, I see this particle labeled 1 moving with velocity v1. Now, when I say v1, it is as good as saying this is velocity of 1, but with respect to what? The ground frame. When I don't use the second subscript, it is understood that I'm talking from the ground perspective. Yes or no? Okay. Let's say this champa or this particle 2 has some velocity like this. I call it v2 bar, or it is same as saying v2g. When I don't use the second subscript, it is understood it is with respect to the ground. Great. Now the moment I ask something like this, what is velocity of 2 with respect to 1? This is velocity of 2 with respect to 1. That means 1 is the observer. So when the observer sees himself or herself, what will they be seen doing? Answer it in the chat box. If the observer sees themselves, what will they see themselves doing? Observer, I am looking at myself. Will I see myself moving? That is like my ghost is moving? No, right? I will see myself at rest always. Always at rest. Very good. Correct. You will, if the observer sees himself or herself, they will always see themselves at rest. Correct. So, when I say this velocity of 2 with respect to 1, that means you are saying this person 1, this Pandu should see himself at rest, and he should only see what is remaining of 2. So, he should only see the relative motion of 2, not his own motion. I might be moving, somebody else is also moving. I see myself moving with respect to the plants, the buildings, the trees, the flyover, the roads, everything. Yeah, I am moving, boss. Yeah, I can see the roads going behind me. But when I see myself at rest, I am making everything come, in my perspective. I am taking out my velocity. I'm sucking out my velocity. So if I had a speed of 100 kilometers per hour, I'm saying, okay, now everybody, I am moving at 100, so take away 100 kilometers per hour from you. Whatever is remaining is your relative velocity for me. So I can then say V21, velocity of 2 with respect to 1 is nothing but, you were moving with some velocity, okay, V2 velocity. From that, you suck out my velocity. Whatever is remaining will be the relative velocity. Is this now making sense to all of you? Is this equation making sense to all of you? Yeah? Making sense? Clear? Yeah? I make myself at rest, so I'm sucking out, I'm removing my contribution. So whatever is remainder will be the relative motion. So then it also makes sense to say when I use the term V12, which is velocity of 1 with respect to 2, then I can also say that in this scenario, with respect to 2, so 2 sees himself or herself at rest. So when you look at 1, you tell 1, okay, you are moving with some V1 velocity. From your velocity, take out my velocity. Whatever is remaining is your velocity. And you can now see that V21 is V2 minus V1, V12 is V1 minus V2. Obviously, they are negative of each other, which was expected. They are definitely negative of each other. So, as seen clearly, so therefore, also it implies that V12 bar is negative of V21 bar, which was already shown. It is just reiterating that same fact, nothing new. We saw this already. So that is how we define relative velocity in terms of those two other velocities, which are with respect to ground. But can I use the same thing for acceleration? Of course. Displacement? Of course. Position? Of course. So relative acceleration of 2 with respect to 1. A21 will be A2 minus A1. S12 will be S1 minus S2. R21, R2 minus R1. S12, S1 minus S2. So anything is there. Acceleration, velocity, displacement, position. Acceleration of the monkey with respect to donkey. It is acceleration of monkey minus acceleration of donkey. Acceleration of thief with respect to astronaut. It is acceleration of thief minus acceleration of astronaut. What is the displacement of elephant with respect to snake? Elephant minus snake. That's it. Always first minus second. Always. Is this clear? This is how the formula goes. Every single time. And here, I know we were missing that term, which is G over here, which is okay. Okay to write. It's okay to not write also. But what if this was not ground? What if it was something else? Let's say it was some third frame altogether. What if it was some number 3 frame? Then I would say that V12 will be nothing but V1. V1 is as it is over here. But this will be, please remember, velocity of 1 with respect to 3. Velocity of 1 with respect to 3. So instead of G, I will use the number 3 minus V2. Maybe this is some velocity of 2, but that velocity of 2 could have been with respect to that same thing which is over here. So this would be technically 3. So instead of V1G minus V2G, that G has been replaced by that number 3 over here. What is 3? 3 could be anything, boss. It could be a bird, aeroplane, it could be some object, it could be a lift, it could be some person, it could be anything, some random frame. So whenever you find relative velocity, you subtract the velocities with respect to the same frame, V13 minus V23. Don't say V13 minus V24. No, it should be with respect to the same frame. But then I have a proposition which is very interesting. What if I move this guy over here? And then you will see one very interesting thing. This will be V12 minus will become plus V23, okay, will be equal to V13. Very, very interesting. Look at it. You started from 1 and went to 3. V13 is V12 plus V23. So you have brought that number 2 in between. First 1, 2 were there, and then next 2, 3 was here, and you ended up from 1 and you jumped directly to 3. This gives me an idea that maybe I can generalize this. Maybe I can generalize this and then say that, listen, if I want to find V13 or V12 or V16 or V10, V5A, V anything with respect to anything, I can open it up. As long as my first and the last alphabets are same, I can make it like a chain. From 1 to 2, 2 to 3, but I started from 1 and ended at 3. Same thing I do it here. Observe, I can write it like this. Is V1A plus VA3 plus V34 plus V4D plus VDE plus VE, maybe I'm getting bored, I will stop it now. Okay, VE2. As you can see, a beautiful chain has been formed, but the first alphabet is here, the last alphabet is the second one. That's it. So can you see a chain being formed? So this is a chain rule of relative velocity. You can use this always. Velocity of monkey with respect to donkey plus velocity of donkey with respect to zebra, velocity of zebra with respect to elephant will be equal to velocity of monkey with respect to elephant. The first animal to the last animal. In between, as many terms you can build in. So you can apply the same thing even for acceleration. Acceleration AB will be acceleration of A with respect to O plus acceleration of O with respect to C plus acceleration of C with respect to D plus acceleration of D with respect to B. You can also use for displacement. Displacement of 1 with respect to 2 is displacement of 1 with respect to 3 plus displacement of 3 with respect to 4 plus displacement of 4 with respect to 5 plus displacement of 5 with respect to 6 plus displacement of 6 with respect to, I got bored, I will end at 2. Okay. I can always make this as a chain. So this is nothing but like your chain rule kind of thing in a relative motion. Okay, there is no direct formula, but remember this as a rule. Okay, so this is what we have finally concluded. So usually what are the formulas you will be using? This obviously 100%. If you interchange observer and observed, then they are equal and opposite motions, relative motions. The second one which you'll be using most commonly is this formula. Velocity of 2 with respect to 1 is V2 minus V1, or V12 is V1 minus V2. Okay, this is another most common formula which we'll be using, and the chain rule formula which I have put it over here. So the chain rule is what you will be using very commonly. Okay, always remember when to use chain rule versus when to use this rule. So subtraction whenever it is there, vector subtraction whenever it is there, it is with respect to the same frame. Keep that in mind. Same frame is there. But whenever you want to transition from one frame to the next frame to the next frame, then you use chain rule. Okay, let's do some examples, then you only will get an idea. Yeah. So these formulas, please write it down in your notebooks, in your rough notes. I don't want it to be fair, just write it down 2-3 times so that it will be in your head. So one is this interchanging observer and observed. Second thing is with respect to the same frame, you subtract the velocities or accelerations to get the relative motion. And the third one is the chain rule. 3 important things. By the way, the chapter theory mainly is done. Okay, if you're wondering, main 80% of the theory of the chapter is this much only. After this, it's just different varieties of questions like rain man, boatman, wind aeroplane, chasing. Everything is just now, there could be unlimited, I would say, concepts which you can build upon. Okay, fair enough. Let's start seeing few questions. Do you know how to subtract vectors? Just let me know, guys. Yeah. Do you know how to subtract and add vectors, or do you want me to give a brief idea and then maybe can go ahead with that? Yeah, okay. Basic triangle law, parallelogram law. So just to give you an idea, if I have, what is this? So if I have C vector, which is A vector plus B vector, then maybe this is A vector, and then you put like this the B vector, then this would be your C vector, correct? And if you have something like D vector is A vector minus B vector, because vectors will be needed most likely now. So if you have A vector like this, and maybe B vector was like this, you take the negative of B vector. So this will be negative of B vector. So A vector and negative B vector will be this vector. So that is vector subtraction. Okay. So this is what you will usually use. And if the angle between the vectors is given to be theta, if the angle between the vectors is given to be theta, then the resultant formula also you should know. So the resultant of addition will be root of a square plus b square plus 2ab cos of theta. That is for vector addition. But for vector subtraction, the resultant difference or subtraction will be root of a square plus b square minus 2ab cos of theta, where theta is the angle between the two vectors being subtracted. Okay, so basic things you should know. Apart from that, rest of the things geometrically or trigonometrically you will be able to manage easily. Okay, cool. So let's start then. Here's the first question. Okay, in everything we will try to find velocity of 1 with respect to 2. Okay, also velocity of 2 with respect to 1 will be there, but it will be opposite. So just I'm putting it over here. So what are the different scenarios? So let's say this is 1 which is moving at 7 meters per second, and this is 2 which is moving at 5 meters per second. Then 1 is over here going at 10 meters per second, and 2 is going at 3 meters per second over here. Then 1 is going at 3 meters per second, and 2 is going over here at 7 meters per second. We'll do all kinds of variations over here. all kinds of variations. Then maybe 1 is going at 1 meter per second and 2 is going at 11 meters per second. Then maybe like this, 1 is going at 8 meters per second and 2 is going at 3 meters per second, like this. Okay, so both going same way, both going opposite, both going towards each other, both going this way, all kinds of variations, guys. Okay, and yeah, I think this should be good enough. Let's try to find it out. Let's start with the first one. Okay, let's start with the first one, guys, everyone. So in this case, V12, if I try to find it out, V12 is nothing but V1 minus V2. So everywhere I will put V12 is V1 minus V2, and then here V21 will be V2 minus V1. All the speeds are with respect to the ground, so I don't have to break my head. So in the first case, V1 is 7, V2 is 5. So 7 minus 5 means 2 meters per second. If you do this, V2 minus V1, V2 is basically 5. V2 is basically nothing but 5. And V1 is basically 7. So it will be negative 2 meters per second. What does plus 2 stand for? What does minus 2 stand for? See, understand. Plus 2 means if you see over here, V12, that means observer is 2. So if you are in this vehicle, if there is a vehicle behind you coming at 7 meters per second, you will see that vehicle go in the positive side, which is your right side, this way, at 2 meters per second. Kind of makes sense. Just visualize it for a moment. See, getting it answers is very easy with the formula. That is not the point. Let's visualize it also every situation. When I say V21, I'm sitting on one. I'm in the faster vehicle. There's a vehicle ahead of me which is moving slower. I am moving towards it. So as I move towards it, it will approach me in this way, which is left side, which is negative. So that is why automatically it came out negative. I don't have to break my head. Is that right? Now, same thing. Try to do it over here. V21, for example, V2 minus V1. So it will be 3. But a lot of people are going to put 3 minus 10. That is wrong. That is not 3 minus 10. It is 3 minus minus 10. Can you tell me why it is minus 10? Can you tell me why it is minus 10? The direction. Velocities are vectors, sign sensitive. Even acceleration and displacements are. So be careful. It is negative 10. So minus minus becomes plus and it will become 13 meters per second. Okay. And over here, V1 minus V2. So it will be minus 10 minus plus 3, which is minus 13 meters per second. Obviously, it has to be negative of each other. I didn't do it directly. I wanted to use the formula. If you picturize it, V12, velocity of 1 with respect to 2. So 2 is going this way, 1 is going that way. So I moving this way, I am seeing something going that way. So I will see it going faster away from me. Because both of us are going the opposite directions, it will be faster. And that's why I see it going with negative 13 because I'm seeing it going towards your left side, which is negative. Whereas this one, if you see V21, the pink one, velocity of 2 with respect to 1, I am going this way. I see something going that way, that side. So right side means positive. So, and it is going to be faster because I'm also going this way. You are going that way. We are separating out. So obviously speed will be more. So it will be 10 and 3 together, which will be 13, opposite direction. Great. Okay, now we'll stop visualizing because you have got the idea how to visualize. You can obviously do it at home. Again, you can spend some time there. So this will be nothing but, what is it? V1 minus V2. V1 is 3. V2 is minus 7. A lot of people will just write 7. That is not right. So it will be nothing but 10 meters per second. So if you do the same thing here, V2 minus V1. V2 is negative 7 minus plus 3, which is minus 10 meters per second. So no matter which question, you can easily do it now. So this one then, over here, V12, V1 minus V2. V1 is 1, V2 is 11. So it will be 1 minus 11, which is minus 10 meters per second. Here, V1 minus V2 is minus 8 minus 3. So minus minus becomes plus. So 3 minus 8 is minus 5 meters per second. Okay. Same thing. Let's do it over here. V2 1. V2 minus V1. V2 minus V1. So it will be 11 minus 1, which is 10 meters per second. You can cross verify they are equal and opposite. Here, in this case, V2 minus V1. So minus 3 minus 8, which is 8 minus 3, which is 5 meters per second, equal and opposite. That's how you can do it. Clear, guys? Any question now? Relative velocity or acceleration or displacement you can solve. See, I have put units as meters per second. If I had put meters, still you will do the same thing. If I had put meters per second square, still you would do the same thing only. No, you will not use your new brain. Oh, I have to solve that problem differently. It's the same formula, guys. Instead of velocity, I can use the word acceleration or displacement. It is one and the same thing. Yeah. Perfect. Clear. All right. Amazing. But sir, now I sometimes might not be so much interested in the signs, sir. I mean, V12 or V21, 2 or minus 2, minus 13 or 13, 10 or minus 10. Many times I'm just interested in the magnitude, sir. You know, I'm just not interested in the sign because I'm just interested in the relative speed, not velocity. Often you will get such questions, especially the chasing questions, meeting questions. When do they meet? When do they chase and touch each other? So many such questions. That time, I would say, although you can use vector subtraction, although you can be conscious about the signs and then do it, I would say that still utilizes maybe 5 of your brain cells and maybe it takes that extra half a second of your time or 1 second of your time. I can save that for you. Okay, we can do that. How, sir? Observe carefully. When the question is on relative speed, not velocity, okay? Because speed means magnitude. So this is nothing but relative velocity's magnitude. Okay, we are talking about the magnitude of it. We are not interested plus 13, minus 13, plus 7, minus 7, minus 10, plus 10. I'm not interested. Then there is a simple trick to get it. What is that simple trick? Observe carefully. The relative velocity, relative speed, without the bar. Okay, this is relative speed I'm talking about. Without that bar means it is scalar. Will be equal to, just take the magnitudes and add them, or at times you take their magnitudes and subtract them. V1 minus V2, but I don't know who is bigger, so I'll put a mod symbol over here. Always it will be a positive number. Either it will be subtraction or addition. But when do you add, when do you subtract? So where you have to add is basically when they are approaching each other or going away from each other. This situation or this situation. Basically, they are either approaching towards each other or going away from each other. That means the directions are opposite. Directions are opposite. And you will use subtraction when they are chasing each other. One is fast, one is slow, one is slow, one is fast. Either left side or this side, doesn't really matter. Whenever you see chasing, that means same directions, then you will use subtraction. Here they are usually chasing. Here they are basically chasing. Whereas here they are approaching each other or away from each other. Okay. So is there a trick to remember? Sir, I will get confused. I'll tell you. Directions are opposite. What is the symbol for opposite in English, Hindi, Tamil? Yeah. Yeah. The subscript coming at the second is usually at rest. Yes, correct. not usually, it's always Kohan. Okay, so it is with respect to that Kohan. Opposite the symbol is like this, no? Opposite the symbol is like this. This is that cross symbol. You just turn it. What does it become? Plus. So when the directions are opposite, it is plus. Yeah. Opposite symbol is like this. So you turn it, it is like that. Plus. Same direction. Same. Synonym. Equal to. You use equal to symbol. Equal to is like this. Merge the two lines together. What symbol does it look like? Minus. Simple now. You will never ever forget this. Yeah. So opposite directions, cross, plus. Same directions, this way or that way, merge them, it will become minus. Super. Okay, let's see whether it works. In all these examples, everybody try it mentally. Okay. Forget the sign. Forget the sign. Tell me the first problem, chasing or opposite? Same direction or opposite? First problem, they are chasing, same direction. Same means minus. 7 minus 5, 2. Oh, perfect. I don't worry about minus or plus. Speed I am interested in, relative speed. Simple dimple. Yes, correct. Here, opposite, plus 10 plus 3, 30. Perfect. I don't have to break my head. Isn't it? Here, they are going in opposite direction, 7 and 3. Opposite means plus. 7 plus 3, 10. Perfect, guys. See, so simple it is. Okay, let's go over here. Where is it? That other. There was one more. No? It's like, oh, I think it went here. Yeah, all right. Here, going in the same direction. Same direction means subtract. Same means subtract. Don't subtract 1 with 11. 11 with 1 will be better because big minus small. Okay, big minus small. So 11 minus 1 is that 10. Perfecto. Here, 8 and 3. Same direction. 8 minus 3, 5. So answer is 5. Perfect. We got it. So this is how you can solve it. Mind blowing, Vidika. Perfect. Amazing. Great. So this is how you can solve questions for relative speed only, not velocity. Velocity means sign. Then you don't use this. Then you don't use this. Then you just go with the standard formula, which is also very simple, guys. I mean, it's not big deal. Okay. So let us solve the next question coming up on your screen. Displacement of 1 with respect to 3 is minus 7 meters. Displacement of 3 with respect to 4 is minus 2 meters. Displacement of 3 with respect to 2 is 5, let's say 10 meters. And let's say displacement of 2 with respect to 1 is, let's say, 4 meters. Chumma, I have put some random values. Question is, find the displacement of 1 with respect to 4. Find the displacement of 1 with respect to 4. Let's see how many of you can use your brains and get the answer. It is very simple. You just have to manipulate it. Okay. Let's see whether you can do it. Relative displacements are given. Can you find the relative displacement of 1 with respect to 4? Straightforward. I think we have to use chain rule. It is kind of obvious by now. S14, if you expand it, it will be S1 maybe 2 plus S23 plus S34. If I know these three things, I think I should be done with it. S12, S23 and S34. I think something extra data is given. Maybe S12, S23, S34, S13 shouldn't have been given. I'm so sorry, guys. This shouldn't have been given. By mistake, I gave you that extra data. So sorry. Just remove it. It was not needed. Yeah. Okay. Now we can do it, guys. I think we can do it now. Just check it out. How do we do it? Yeah. S12 is not given, but I know it is negative of S21. And S21 is given to me over here. Perfect. This is taken care of. S23 is not given, but S32 is given. So it is negative of S32. Okay. Plus or minus, I don't know. Okay, so this is also done. 34 is directly given over here. So I can just put S34. Okay, now this is solvable. So S21 is 4. So put 4 over here. S32 is basically 10 and S34 is basically minus 2. Okay, so minus 4, minus 10, minus 2. 10 plus 4, 14 plus 2, 16. So minus 16 meters per second. Sorry, just meters. That is the answer for S14. Is this absolutely clear, everyone? Yeah. Minus 16, huh? Minus 16, not plus 16, minus 16 will be the answer. Very nice. Very nice. Let's see the next question coming up on your screen. Next question. A person is walking. A person is walking in a train along its motion with relative speed of 5 kilometers per hour. The train moves at 70 kilometers per hour. 70 kilometers per hour. If there is a bus moving in opposite direction at 20 kilometers per hour, find relative speed of person with respect to the bus. Find the relative speed of the person with respect to the bus. I think you should draw the diagram so that you get an idea. So let's say this is the train, okay, and that train obviously is given to be moving at how much? 70 speed. There is a person inside that train. He is moving in the same direction inside the train with a relative speed of 5. There is a bus. It's going like this. Just 1 second. Okay. Yeah. So this is the pictorial representation of words. Pictures might not be always given. Okay. You will have to visualize it in the rough sheet. Okay. Fair enough. Now, first things first, we have to find the speed of the person with respect to the, whatever, that bus. So let's just do it both the ways. I can do it by pure visualization. I can do it by pure mathematics and equations also. Like whatever is given to me, if I write it down, strictly speaking, I have been told velocity of the person with respect to the train is 5. Velocity of the train with respect to the ground is basically 70. Velocity of the bus with respect to the ground is negative 20 if I use the sign convention. 5 and 7 are right side, 20 is towards the left side. What has been asked as per the question, velocity of the person with respect to the bus. Velocity of the person with respect to the bus is asked. So think about it, velocity of the person with respect to the bus in these terms, if you think carefully, it will be velocity, use chain rule, of the person is directly associated with the train plus velocity of the train with respect to the ground plus velocity of the ground with respect to the bus. So VPT, VTG, VGB. So if you do that systematically, you will get the answer. What is VPT? It is already given, it is 5. What is VTG? TG is basically 70. Okay, what is GB? VG is given minus 20. So GB will be negative of negative 20. Do you understand? VGB is negative of VBG. So minus of minus. VBG was minus. So minus minus becomes plus. So 75 and 20. That is going to make it 95 kilometers per hour. How many of you got this? Very good. No, not not 85, not 155, not 25. Okay, is this clear? Yes, Vedika, that is absolutely correct. Yeah, Shravani, sometimes what happens because of teaching, no, that throat dries up, so I need to keep hydrating myself. I forget sometimes. Yes, correct. Yeah, cool, perfect. This was pure mathematics, no visualization needed at all. Did we visualize anything? Nothing. Direct application of formula, straightforward. This is usually the safest method, but often the lengthy method also. If you visualize, it can lead to silly mistakes, but you will get the answer quickly. So it depends from person to person. It's a personal choice. Don't bring it on ego. So I want to do it fast. What is the use of doing fast? Like, I met one student in one Vedantu learning center, and he was like, "Sir, I am the fastest calculator. I can calculate anything." And I was stunned. You give him any number multiplied by any number divided by any number. Within 1 second, that student gives the answer. I told him, okay, so we took a demo. 1,28,000 into 758. And then the student was like 2,000. I was like, bro, I told 1,28,000 into this thing and you are telling the answer is 2,000. And the student was like, yes, sir, I just told I calculate very fast. I never said I can do it correctly. I was like, man, students are next level. I should upgrade myself. So that is the joke. So, guys, so you think which one will work for you, accordingly you suit yourself. Okay. So how I can visualize? How I can visualize? See, I am moving inside the train, and train is also moving. So I already get the train speed and plus my own speed. So technically that person will be moving at 70 plus 5, which is 75 with respect to the ground. Makes sense? The train is moving, and for the train you are moving the same direction. So both the speeds will add up, and you will have a speed of 75 with respect to the ground. And this bus is moving. This bus is moving like this with a speed of 20. Opposites means plus. So the relative speed will be 75 plus 20, which is 95. So directly you can get the answer. So that is visualization. I won't even draw much things. I just think, okay, for the train I'm moving like this, it's 75. Bus is going opposite. Opposite means plus. So plus means 75 plus 20, 95. So that's all. So that is visualization method. Clear, everyone? Yeah. Okay, great. Next. Now let's do some questions where overtaking, chasing, meeting are involved. Okay. So now let's start applying these things. Now we all know that distance divided by time is speed. But just add the word relative, it works. So relative speed is relative distance by the time. Time is also relative, but for our normal things, time is going to be the same for almost most of the things around us. So what do I mean by that? Say I am standing and some person is in a train. For me, if something takes 1 second, I don't know, my respiration rate. The train person will also say, yeah, it is 1 second only. Or whatever. So many respirations are happening in 1 minute or whatever. But there is actually a minute error which is maybe in the 8th, 10th, 20th decimal. which is often neglected, and that is the relativity effects. So the time will start moving at a different speed for a moving person. So if you're in a spaceship and it is moving, then Einstein said that the person in that spaceship will start finding things a little bit differently. But those effects are so small at normal speeds. Only when you approach speeds of light, then you start noticing that effect. And then, maybe a minute spent here might be 1,000 years in some another spacecraft. Yeah. So you might have seen that in the movie of Interstellar. They go for a couple of minutes over there, and in that spacecraft, around 20 or 21 years are being spent. So that is that concept of relativity, which we will not bother now. Although ideally this should have been relative time, we will ignore this concept. We will ignore, relativity, concept. Deliberately I am putting that cross symbol. So this is only for small speeds, meaning they are much, much lesser than the speed of light. The speed of light. Then I can use this formula, of course. So this is the formula which I'll be using. Then relative distance by relative time not needed, by time is the relative speed. So very, very useful. Okay. Miller's planet, correct. Very true. Everybody has seen it. Yeah, around, I think it is 18, Mayank, if I'm not wrong. Is that right? 18 times you will breathe in and out respirations in a minute for an average adult. 16 is also, yeah, there. 12, I think, is low, no? Or is it like humans have changed by the time I have grown old? I'm not really sure. 12, I think, is quite on the lower side, I guess. There is also a theory that the animals which breathe very fast, they live for a shorter time. The animals which breathe slowly, they live for a very long time, like tortoises. Yeah, they breathe very slowly. Whereas dogs, if you have seen the dog, that's how they breathe, right? Even normally, not even when they are running, but even normally, that's what you see. So they breathe very frequently, and the span of a dog is barely 12 years. Yeah, tortoises live long around it. Tortoise like, I should breathe. Okay, I'll open my mouth. Oh my God, so much energy. Leave it, man. So slow, steady, around it. Anyways, so let's do some questions. So imagine this Pandu is running with a speed of 20 meters per second towards a Champa. I don't know why he's running. Champa is getting scared, and Champa is running at 5 meters per second. And originally, the distance between them was maybe 60 meters. So the question is the time after which Pandu will catch Champa. That is the question. The time after which Pandu will catch Champa. So if you see over here, this is a question of relativity, relative motion, sorry. Minimum 20, max 20. Oh, is it? So, good. So you guys have learned biology recently, I guess. So, this is a concept of relativity. Either you sit on Pandu or sit on Champa. I mean, not literally, the observer. So just see what is the relative speed. So relative speed, because they are in the same direction, that means you have to subtract. You have to put minus. 5 and 20 are in the same direction. So 20, bigger number, minus the smaller number. That will be 15 meters per second. This distance is the relative distance because, see, if both Pandu and Champa were at rest, that distance would never change. If both Pandu and Champa moved with the same speed, that distance will also not change. Imagine Pandu moving at 5, Champa also moving at 5. 60 will remain 60. So that relative distance is always going to be the same if they're at a rest or both moving with the same speed in the same direction. But it only changes because of the relative speed. So that distance has been traveled relatively with respect to each other. So if Champa sees Pandu, Pandu will be observed coming closer, traveling relatively by 60 meters. So relative distance is 60. So 60 meters is relative distance with respect to each other. So speed, distance and time, I just told you. Distance by time is speed. That's it. Use that formula. Nothing more is needed. So distance is 60. Uh, Time I do not know. Speed is basically 15. So therefore, time is 60 divided by 15, and hence it is 4 seconds. So within 4 seconds, Pandu will be at par with Champa. Is that making sense? Yeah. Perfect. Let's go to the next question coming up on your screen. Here it is. Let's go to the next question. There is a van like this. It's going at 72 kilometers per hour, and there is a bus over here which is going at 36 kilometers per hour. The distance between them right now, okay, is maybe around 120 meters. Question is the time after which they will collide. The time after which they will collide. That is the question. Now you might wonder, will the speeds remain the same? Yeah, let's assume both the drivers are sleeping. They slept off, dozed off. Now the vehicles are going on autopilot. Tesla, but Tesla can brake. But this is not Tesla bus or Tesla van. They will go at the same speed. When will they collide? So as you can see over here, first we can start off with what is their relative speed. So what is their relative speed over here? They both are going the opposite direction. Opposite means plus. I'm interested in speeds. So 72 plus 80, which is 90 kilometers per hour. But I think better to convert it into meters. So 90 into 5 by 18 meters per second, which is nothing but 25 meters per second. Is it 25 meters per second, everyone? Yeah, perfect. Now again, this is going to be the relative distance between the buses. So one bus looks at the other bus, the bus will approach towards itself 120 meters. Perfect. So distance is 120, time I do not know, speed is 25. So therefore time will be 120 by 25 divided by 5 is 5, divided by 5, that is going to be how much? That's going to be 24. That's going to be 24. So 24 by 5 seconds. That's what you can say. Everyone? 24 by 5. Yes. Sir, is it 72 plus 80? Oh, sorry. I misread this number 36 as 18. I'll change the question only. Or okay, I have to solve it as per the question, then it will be better. Oh, so sorry guys. I gave a wrong answer. I printed or I typed the wrong thing only over here. Yeah. So this was 36. I'm so bad. Yeah. So 72 and 36. Yes, this will be 108. 108 kilometers per hour. 108 kilometers per hour. Yeah. Is that fine? Yeah. My bad. Yeah. Okay. So now you convert it into meters per second. 108 into 5 by 18 meters per second. So 18 goes with this. 6 times 6 5s are how much? 30. So 30 meters per second. Yeah, perfect. Okay. So distance is 120. Time I do not know. Speed is basically 30. This time I will get the time as 120 divided by 30. This is fine. So time is basically 4 seconds. This is okay. Cool. Perfect. So these kind of questions are usually very straightforward. But then look at this question. They will tell you, listen, there is a bus like this. That particular bus has a length of maybe 10 meters and it is moving at maybe 20 meters per second. Then there is a car or something behind like this, okay, or a van or something, and maybe the width is just 5 meters, okay, and it is now moving at maybe 25 meters per second. So this is faster, this is slower. The bus is slower, the car over here is slower. This is that bus. The question will be, how much time will be taken for the overtake, number one, and what is the road distance? What is the road distance by the car? What is the road distance by the car to overtake? Very, very interesting question. Okay, read it again. Let's understand the situation. What is the true meaning of overtake? The true meaning of overtake is like this. This is that bus. This is that car over here. So the overtaking begins the moment the front of the car is behind the bus. Now the bus will keep traveling. The car will also keep traveling. Eventually the bus will reach here. The bus will reach here, let's see. And the car should reach here. That's it. The car should reach here. That's it. The back of the car should just cross the front of the bus. Then you have overtaken. Is this absolutely clear? What is the meaning of overtake? Yeah. So the front of the car is behind the bus. Then the back of the car is in front of the bus. So this is how it will look from the ground frame. So this was your road maybe. This was your road. This was your road. Okay. Which this happened. Now, this is all from the ground perspective. This is all from the ground perspective. But if you change your perspective to maybe the bus or the car, then it will be very simple. Let's say if you go from the bus frame of reference, then for you, the only thing that the car has to do is it has to travel relatively, and after some time it has to just reach here. After some time the car has to just reach here. So technically speaking, the car has to travel like this. So this is the relative motion which the car will have to do. Are you able to visualize this? If you make the bus as your frame of reference, this is now relative. Bus relative motion. How many of you understood this? So now think and clearly tell me what will be the relative speed between them. They are in the same directions. Same direction means minus. Same direction means minus. So it will be 25 minus 20, which is 5 meters per second. Which is 5 meters per second. Correct? Everybody till this point? You okay, sir? So, what is the relative distance? If you think carefully, it will be the bus length plus the car length. The front of the car has to reach here. That means this extra distance also you have to cover. So, technically, that distance will be 10 plus 5, which is 15 meters. Is the relative distance, because everything is now from the bus frame. So if you use that concept, relative distance is 15 meters, time I do not know, and speed is basically 5. Therefore, time is 15 by 5. So the time is 3 seconds. So it will take 3 seconds for the car to overtake. Okay. Akash, which part you want me to repeat? See, this was all from the ground frame. The bus is going. Zoom, it is going like this. This car is coming fast a little bit. It will overtake it like this. Now, this was all from the ground frame. But when you sit on the bus, the car will be here. It will just have to go like this, from here to here. So it has to not only travel the length of the bus, but also the length of the car, so that no part of the bus or car is overlapping. So there is no overlap. So here is the first instant when they just are in front, and then the back part is with the front of the bus. That's it. So this is the overtaking length. So 10 plus 5 is 15 meters. That's the relative length which the car has to travel. And distance by time is speed. Distance is 15, time I don't know, speed is 5. Why is it 5? Because they are moving the same direction. And whenever the directions are same, minus. Remember, I just given you the trick. Got it? Clear, Akash? Okay. But our one answer is still pending. Road distance traveled by the car. What is the meaning of the road distance traveled by the car? It is basically this distance, guys. It is basically this distance. This distance is that road distance which has been traveled by the car. This is that road distance which has been traveled by the car. Okay, road distance which you need. So, this whole thing will be that road distance, how much the car has traveled. So, if you see, I need this much width of the car and all this length which the car has used up in this due process. Yeah. So, the road distance means how much part of the road did the car use? How much distance on that road did the car use to overtake? Please remember 15 was relative distance, not road distance truly. Is that okay? Yeah. So how much will that be? I'll tell you one thing. See this much part. Yeah. This much part here is just 5 meters. From here to here, the speed of the car, how much was it? 25 meters per second. You multiply it by the time taken to overtake, which is 3 seconds, which is going to give me 75 meters. So this to this is 75 plus this extra 5. So the road distance which is used by the car, how much gets? 75 plus this extra width of the car, which is nothing but 5. 5 plus 75, which is 80 meters. Yeah, everyone, not 85. You added extra 5 over there. So be careful. The front of the car has traveled 75 meters plus the length of the car, which is 5 meters. I think some of you added extra 5 meters. Very good, Sabri. Yes. Is that okay, Tejaswini? Yeah. Clear. Very good. So these kind of questions are also very, very popular on distance, time, and speed. Okay. Great. What would you do if the bus and car were in opposite directions? Can you quickly calculate the time mentally now? What if the bus and the car were going in opposite directions, and then the question will not be overtaking. How much time will they take to cross? Diagram wise, it will be similar only. I mean, if you use relative frame, the bus is going like this, the car will be here, and later on that car has to come over here. So just think relative distance and relative speed. Easily you will get the answer, guys. Just think carefully. Orally you can answer this. Orally. Tejaswini, the arrow started from back of the car in this case because this particular part of the road was also used by the car, right? The car is not a point. The car also had length. So that's why we use this extra length of that car, which was actually on the road, this much part of the road, and how much ever the car traveled on the road, this much part was the total road distance used in the overtaking. Yeah. If the question was how much distance road it traveled, then the answer will be 75. How much road distance was used by the car in that overtaking process, then you have to add plus 5. Okay. Traveled will be 75 meters. Road distance used will be 80 meters. Small difference in the wordings. Okay. So yes, they are moving in opposite directions. So 25 and 20. So 20 plus 25 will be the speed and distance will be 15 and this will be the time. So time will be distance by your speed. 20 plus 25 is 45. Divided by 5 is 3. Divided by 5 is basically 9. So 3 by, why I did all this? Just 1 by 3, no? Just 1 by 3. So 1 by third of a second. 1 by 3 of a second. Yeah. 1/3 of a second. Not 11 by 3. Not 3 by 5. Not 15 by 45 is 1 by 3 only. Yeah. Got it? If both were going in opposite directions, then the time taken to cross. Okay, that's how I will do it. It's the same thing. 15 will be 5 plus 10 because that will be the total length that they will travel. Okay. So these were the kind of questions which we have solved today. These were mainly one-dimensional road distance chasing meeting questions. Next lecture we'll do more questions on relative motion and we'll slowly move our focus to two-dimensional also. Yes, let's go to the second lecture of your relative motion. Last lecture we did some amazing concepts. Hi Mayank. Hi Anya. Hello, welcome everyone. Yeah, so where we did about how do you measure relative velocity of 1 with respect to 2. It is v1 minus v2, and it is also the negative of 2 with respect to 1. We also saw how to use chain rule in relative velocity. 1 with respect to 2, 2 with respect to 3, 3 with respect to 4. If you add them all, it is 1 with respect to 4. So we saw the chain rule as well. And mainly we did some questions on distance, speed, etc. Everything was in one dimension. We'll slowly push ourselves to 2D and we'll solve some kinematic based questions as well. Okay. Good night. Good night, MD. So remember, whenever you meet anyone, you should never use good night. Even if it is actual night or at 11 o'clock, even 11:30, you meet someone, you never say good night. Whenever you meet, you'll always say good evening. And even if you're leaving early, let's say at 7 o'clock, 8 o'clock also, you will always say good night. So that is how, the etiquette English language is. Okay. Yeah. Right. So let's begin one by one. Now, imagine I give you a question like this. Say, velocity of Pandu is 2i cap minus j cap plus 3k cap. Velocity of Champa is minus I cap plus 4k cap. Can we now figure out what is the velocity of Pandu with respect to Champa? Velocity also of Champa with respect to Pandu. Can we find these both things? Definitely we should be able to do it because VPC, V12 is V1 minus V2. So this will be VP minus VC. And this, either you can use VC minus VP formula, or since you have already found out that, it's also better to use, it is negative of VPC. Any one of these formulas I can use, since we already would have found this. So what is VP? VP I know is right over there. So 2i minus j plus 3k minus VC, which is minus I plus 4k. So as you can see, minus minus will become plus. So I plus 2i will become 3i. For j, there is nothing. So just minus j cap. 3k minus 4k is just minus k cap. So that is velocity of Pandu with respect to Champa. As you can see, this is a three-dimensional question. So there is no rule like whatever things we learned last lecture is just for 1D. You can apply it for 2D, 3D, motion in a plane, motion in anywhere. Once you learn motion in 1D, you learn motion in 2 and 3D automatically. So for this guy, velocity of Champa with respect to Pandu is negative of this. So it is negative of 3i minus j minus k. So hence it will be minus 3i cap plus j cap plus k cap. That is velocity of Champa with respect to Pandu. Exactly opposite. Understood how to solve this? Yeah, this is just pure IJK kind of question. But obviously, nobody is going to give you such simple questions unless it's a part of a bigger problem. That's a different story. What if it is a diagrammatical question? Like, say, this way. Imagine there is a car. Imagine there is a car which is going at 12 meters per second like this. And maybe there is a bus over here which is going towards the east direction, maybe with 5 meters per second. And then the question says, can you find out the relative speed of the bus with respect to the car, or car with respect to the bus? Since we are talking about speed, we are interested more of the magnitude. We can also figure out the direction. It's not that big a deal. So let's say we put relative velocity only. So relative velocity of the bus with respect to the car. So that's what we are interested in. First of all, let's see symbolically what do we exactly need. Velocity of the bus with respect to the car means I need velocity of the bus and I have to subtract it with velocity of the car. That's what exactly I need. Yeah. Okay. Now, what is velocity of the bus? As you can see over here, it is clearly, you can see it is 5 I cap. It is 5 I cap. Can you see that? What is velocity of the car? Right side is x-axis, this is negative x, upwards is positive y, downwards is negative y. Car velocity, it's definitely 12 j cap. That's it. So this is VBC in vector form. This is vector form. But if we are asked the magnitude of it, then it will be nothing but relative speed. Relative speed. So that would be root of 5 square plus 12 square, which is 25 plus 144, which is 169's root, which is a perfect square, which is 13 meters per second. So that is the relative speed between the bus and the car. Okay, this is the speed. What about the direction? Well, 5 I cap and minus 12 j cap. That's enough to give you the idea. 5 I cap will be here. 5 I cap will be over here. Minus 12 j cap will be downwards like this. So the resultant velocity will be here. So this will be your velocity of the bus with respect to the car. This particular direction. Is this clear? This is how it will look like. Yeah. Everyone, if the angle and anything else is asked, you can easily find out that angle. So I know this will be 5 units. I know this will be 12 units. So tan of theta, opposite side by adjacent, which is 12 by 5. So theta will be tan inverse of 12 by 5. This angle is made with the east direction. So we can say that this was east as given in the question, and this was the north direction. So it makes this much angle with the east direction. It is making this much angle with the east direction towards the south. It's not towards the north, it is towards the south. It is towards the south, because there can be two possibilities. If I say 30 degrees, it can be this side or this side with the east. But I'm ruling out this side, so I'm considering this one as given in the diagram. Cool? Yeah. Understood, guys, how to solve this diagrammatical questions? Can we do one more question then? Can we do one more question? Yeah. Oh, no problem. MD. Okay. Yeah, we have actually used Pythagoras theorem, right? Okay. Let's do one more question over here. A ship is moving north with 20 meters per second. A bird flies at the same speed, 20 meters per second, making 60 degrees with the north towards west. Question is, find relative speed between them. Find the relative speed between them. Let's draw the diagrams so that we are absolutely very sure of what we are doing. This is north.
Okay, this is north, this is east, this is west, this is south. So as per the question, the ship is going in the north direction. So this is nothing but velocity of the ship, which is 20 meters per second. The bird is flying at the same speed, making 60 with the north, but 60 with the north can be this side and this side. It says towards the west. So that means the velocity of the bird is like this. So this is velocity of the bird, which is also 20 meters per second. But remember, it is making an angle of 60 degrees. It is making an angle of 60 degrees over here. Okay. Now, since the question says we have to find the relative speed, either this with respect to this or that with respect to this, doesn't really matter. So say for example, we find the velocity of the bird with respect to the ship. It will be velocity of the bird minus velocity of the ship. Minus velocity of the ship means what? You have to take that same velocity of the ship but put it in the opposite direction. So this is negative Vs. This, if this was Vs bar, this is negative Vs bar, vectorially. So that is vector subtraction. So let's do that. Vb is as it is. So it is this way. Vb is as it is. We can just say it is this way. Okay, this is Vb vector. Vs, but with a negative sign, will be like this. So this is your negative Vs vector. Is that fine? This is your negative Vs vector. Now think carefully. If this angle over here was 60 degrees, okay, this angle was 60, how much will this particular angle be? How much will this particular angle be equal to? Obviously, two parallel lines, this intercept alternate angles, this will be also 60 degrees. And it makes sense? Everyone with me? Okay. Also, the best part is that this side is 20, this side is also 20. If I now complete the triangle to get the relative velocity, so use triangle law or parallelogram law, whichever law you want. So that is the velocity of the bus, sorry, not bus, what is it? Bird with respect to the ship. This triangle, I think, is an equilateral triangle because two sides are equal and the included angle is 60 degree. So definitely it is equilateral triangle. It is nothing but an equilateral triangle. So what will the magnitude be of the third side? What will the magnitude be of the third side? That will also be 20 meters per second, which is exactly the relative speed. Which is exactly the relative speed. Is this absolutely clear? How we solved it? So these kind of two-dimensional questions may also be needed at times. Yeah, perfect. Excellent. Okay, so this is how you do things in 2-dimension or 3-dimension. So it could be geometrical, statement based, or just IJK based. Anything can be asked. Now let's do something related to approach and separation also. Okay, let's do something related to separation and approach. So imagine two objects are there. Two objects are there. They might be moving. When do I say they are approaching each other? When do I say they are separating? And when do I say that they are not changing their distance? So here is the situation. If I find, let's say from any frame of reference, let's say for now I'll take the Pandu frame of reference. You can also take Champa frame, there is no harm. If I take the Pandu frame of reference, and I see that Champa's velocity or the second particle's velocity is away from me. So if the relative velocity is away from me, then I will say that is a part of separation. So they are separating from each other. They are separating from each other. But if I find the other particle's velocity towards me, the relative velocity, not actual velocity, relative velocity is towards the other particle, then they are said to approach each other. But in a peculiar scenario, if the relative velocity is perfectly zero, then they are basically not changing their distance between them. So they are not separating, they are not approaching each other. So one way of looking at it is they are neither separating or approaching from each other. And not just that, I would rather say most likely they would be at the closest or farthest separation. Most likely they are closest or farthest separation or distance between them. Or possibility is the distance is not changing only, or the distance between them is just a constant. These are the only three possibilities. Just imagine there is some Champa from my frame, Pandu's frame. I see Champa going away. I'll say, yeah, the relative distance between me is increasing, so we are separating. I see a Champa coming towards me. I'll say we are approaching each other. Makes sense, because for me, if Champa is coming closer, for Champa also, I am also coming closer. Makes sense. In the third scenario, when the relative velocity is zero, it could be possible that Champa was coming towards me. She stopped and then she turned back. Like, oh my God, what happened? Yeah, she was coming towards me and then she stopped and then she went back. When she stopped, the separation between them is closest. We are the closest then. Or the reverse could be true. Champa was running away from me and then she stopped and then she returned. When she stopped, relative velocity is zero. That time the separation between us is the farthest. Make sense? And the third scenario over here, the distance between them is constant. Maybe Champa is just stationary over there. She is not moving relative to me. Maybe we are both moving with the same speed. So the separation between us is just purely a constant. So these are the only possibilities. Are you able to visualize every single possibility? Take some moment, take 30-40 seconds, take a minute, visualize it, say okay then on. Everybody? Yeah. Yes, the third last scenario could be they are moving in the same direction, same speed. So then the separation is not changing. Or maybe they are actually genuinely not moving at all. That is also a possibility. Yeah. So Vedika, once more I will explain these two because this is very easy to understand. If the relative velocity is zero, that means there is no relative velocity. So most likely the separation is constant. One of the possibilities in that. Or maybe imagine that particle was coming towards me, stopped and turned. The moment it stopped, relative velocity at that instant is zero. So when that particle approaching me stopped, that's it. That was the closest the particle was for me. That's why closest distance possibility. Second possibility, the particle was running away from me and stopped before making a turn. At that instant, relative speed is zero. So that moment, it's the farthest from me because after that, again, it's going to approach me. Make sense now? Second scenario, Risha, is basically think a car and bus going in the opposite direction. Yeah, so they are approaching. Or there is a bus, I'm following the bus, but I'm moving faster. So the bus will come closer. So relative velocity is towards me. That is also an example. Yeah. Where it stops, it could depend. It could depend. We are going to solve those questions. Hold on. Yeah. Where it stops, it depends. Let me give you now some examples. Imagine this scenario. You are in this particular car and you are moving at 70 meters per second. And then there is a bus which is going at 50 meters per second. Then you are in a car which is going at 30 meters per second. And then there is a bus which is going like this, maybe at 40 meters per second. Then maybe you are in a car, again you are going at, let's say, 30 meters per second here. There is a bus behind of you and it is coming at 50 meters per second like this. In each scenario, let's think whether we are approaching or whether we are separating. First case, think carefully. Same direction, yeah. So relative speed will be 20. Relative speed will be 70 minus 50, same direction, which is 20 meters per second. But can you quickly think and tell me whether they are approaching or whether they are separating? Kind of makes sense. Like, see, I'm moving faster, this is moving slower, so the distance between them will narrow down. So definitely they are narrowing down on each other. So if you are on the car frame of reference, the bus will appear to come towards you. A bus will approach at 20 meters per second relatively. Bus will approach at 20 meters per second relatively. How about this scenario? Again, you can see that the second scenario, the relative speed, opposite directions. So opposite means plus. So it will be 30 plus 40, which is 70 meters per second. So if you were to sit on the car and then look at the bus, I mean, the car and the bus, the distance between them is becoming smaller. So they are approaching each other, obviously. So the bus will approach at what speed? Approach. Every second, the distance will reduce by 70 meters. This is all again relatively. Make sense, everyone? How about the third scenario, guys? How about the third scenario? Come on, let's see if you guys can figure it out. Direction is same. If the direction is same means what? You have to subtract. So the relative velocity will be bigger number minus smaller number. So which is 20 meters per second. So if you are in the car's frame of reference, what will you see the bus doing? Think carefully. Is it approaching or is it going far away? Is it approaching or is it going far away? Darshan, speed is never going to be negative. Speed is always a positive number. Velocity can be positive or negative. Okay, we are talking about speeds over here. Direction of the speed can be this side, that side. That will be velocity, which is vector, which is sign sensitive. Okay, so never put negative for speed. Okay, for velocity you can put. Yeah, this is also approaching because bus is moving faster. It is going to overtake the car. So the distance between them is going to become smaller. So again, it is also approach at 20 meters per second relatively. All the scenarios where it can go away from each other, like for example, car is going like this at 10 meters per second and maybe the bus is going like this at 30 meters per second. Or let's say the car is going like this at 10 meters per second, but the bus could be moving faster, maybe at 50 meters per second. Or maybe the car is going at 70 meters per second and maybe the bus is just following it at 20 meters per second. In all these three cases, it is just separating. It is just separating. Separation is there. Can you see that? Yes. Car and bus are separating. What is the relative speed? What is the relative speed of separation? 10 plus 30. Opposite directions mean plus. So 40 meters per second. Here, what is the relative speed? Same direction. So subtract 50 minus 10. So 50 minus 10 is again coincidentally 40 meters per second. Here, same direction. Same direction means subtract. So relative speed will be big minus small. So it is 50 meters per second. Why is this separating? Because the car is going to go faster, the bus is still going to stay behind, the separation will increase between them. Make sense, everyone? All these are separation cases. And if you talk about zero relative velocity, maybe the car was going at 40 meters per second and the bus is going also at 40 meters per second. Or maybe the car is going at 50 meters per second like this, and the bus is also going at 50 meters per second. Or possibly the car and the bus both are at rest. The car and the bus both are at rest. So in all these three scenarios, the relative velocity will be zero. Okay, so there is no relative velocity in all the three cases. Everyone understood clearly? Yep. These are examples which I'm taking to make you understand these concepts, or else, it will become slightly tricky later on. Okay, fair enough. Now that we understand approaching and separation, how about taking up a two-dimensional problem of closest approach and separation? See, this is a very good question. Imagine, I tell you, there is one person which is standing over here, and then there is a bus. Then there is a bus over here which is moving. Maybe this is that bus. And this bus is going along this particular line. It's going in this particular direction on this road. This person, this Pandu, is at rest. If I ask you, when is this vehicle or this particular bus the closest to the person, what will your answer be? When is this bus closest to this Pandu standing somewhere on the field, in the house, somewhere off the road? Is not exactly on the road, is off the road somewhere. When will it be closest? When will the bus or that second particle be the closest? Obviously, all other distances are big except for one distance. This is more distance, this is also more distance, even this is big distance, even the separation here is big, even the separation here is big, except for when you draw a perpendicular. Except for when you draw a perpendicular on it. So that perpendicular distance is the closest. So this is the closest distance of approach in 2-dimension or 3-dimension. Closest distance of approach. This is also used in planes, in rockets, in so many other missiles and many other things where analysis is required. Two planes are going, and when are they closest to each other? Two ships are going to go in some different directions. When will they be the closest? What's the shortest distance of approach? When will they be, as close as possible to each other? I've launched a missile, another missile is launched. When will they be the closest? Or I have to jump from one plane to the other. When will they be the closest? Okay, so this is that particular concept. Yeah, it is basically perpendicular. Yeah, you can alternatively say, Sabri, that when they start to separate, then they are at the closest, because here they are coming close, then they go far. So when that coming close becomes going far, that's the transition which happens when you draw the perpendicular. Okay, so this is the closest distance of approach. So at this location, the bus is the closest to the Pandu, closest to that particular person. But this was a simple question. What if the person is also moving and that another particle is also moving? Maybe Pandu met Champa, and after maybe 20-30 years, or when he's 25 years of age, and then Pandu and Champa were talking about their childhood and school and college, and they said, hey, I was at this place during New Year. Really? Even I was there. Oh, really? Where were you? Then Pandu says, I was traveling at 7 meters per second in northeast direction, making some angle, something. So Pandu says his velocity. Very romantic discussion they are having. Okay, it's very romantic. Then Champa gets very happy. She also tells, listen, you know what? I was also there. Really? So Champa starts describing her velocity some 5-10 years back. And Champa says, you know what? I was moving like this. I was moving like this. This was my velocity at that instant, and I was here. Then they start thinking, oh my God, we were there. So when we were having these velocities, when would we be the closest? When would we be the closest? So what do you think, my dear students? What do you think, my dear students? What should we do in such a situation to figure out when are they the closest? Obviously, it's difficult to solve. Yeah, it's like they were tied with ropes. Oops, no, invisible ropes. When one person is at rest, it is easy. When two people are moving, it's difficult. So no problem. Make that one person at rest. Let's kill these lovers. Ayo. Perpendicular. What perpendicular? What do you mean by perpendicular? I should draw perpendicular to whom? People are saying we should draw perpendicular. What perpendicular like this? Perpendicular like this? This is shortest? No, it's not like that. Make one of them at rest. So let's make Pandu at rest. Let's talk from Pandu frame. So Pandu at so everything. Pandu is our frame of reference. This is Pandu frame. Okay, so this Pandu is now at rest. So if that is the case, I have to look at velocity of Champa with respect to Pandu. Velocity of Champa with respect to Pandu is nothing but velocity of Champa minus velocity of Pandu. Oh, vector subtraction, huh, sir? Yes, bro. You have to do vector subtraction. VC vector is as it is. You don't have to break your head. So VC vector is as it is only. That is fine. Okay. So this is VC vector. This is negative of VP vector. Oh, negative of VP vector. Huh? Negative of VP vector will be like this, something maybe. This is maybe negative of VP vector. So the vector addition that will come out like this. So that is velocity of Champa with respect to Pandu. Oh, got it, sir. So now what do we do? See, Champa and Pandu were here, right? Like this. This was their separation initial. So you show, okay, maybe that same separation like this. And now show velocity of Champa with respect to Pandu. This is velocity of Champa with respect to Pandu, like this. So velocity of Champa with respect to Pandu. Velocity of Champa with respect to Pandu. So this same Champa over here, this Champa over here, she is walking relative to that stationary Pandu like this. So when will she be the closest? When you drop a perpendicular on the relative velocity. So this is when Champa is closest to each other. And this is the shortest distance of approach. Shortest distance between them. Is this now absolutely clear? Everyone understood how to solve these kind of questions? Perfecto. How about taking an actual question and then solving it? Okay. This was the concept. We will actually solve a question, maybe taking some values. So then you will get some confidence. So what we can do, you can just say, listen, there are two roads over here. And what happens is, there is one Pandu. He was here. And this Pandu begins to move at 10 meters per second like this. And there is a Champa over here. And she begins to go like this. Maybe I will use some different speeds. Maybe 8 meters per second like this. And Champa is going at maybe 6 meters per second. Initially, the distance between both of them, Okay, I can just take some distance between them. So maybe that distance between them I can just say is 30 meters. You might have taken something. Okay, 30 meters. So question is, when will they be the closest? The time and the distance of closest approach. Time and the distance of closest approach. That is the question. Let's think. How do we solve? Okay. Question is clear. Time and distance. Everything has to be done in somebody's frame. So let's do that. So let's see velocity of Champa with respect to Pandu maybe. So if I try to find velocity of Champa with respect to Pandu, which is velocity of Champa minus velocity of Pandu, of course. So velocity of Champa should be as it is. Oops. Velocity of Champa should be, why so big? Velocity of Champa is as it is. Velocity of Champa is as it is, which is how much? 6 meters per second. But velocity of Pandu should be negated. So I will take like this. So this is negative velocity of Pandu, which is still magnitude wise 8 meters per second only. I'm talking about magnitude wise. So this is negative V. Magnitude wise, it is still 8 meters per second. So if you do vector addition, which is also vector subtraction, that is what our vector will look like. So this is your velocity of Champa with respect to Pandu. This one. Fair enough till this point? Absolutely clear? Everybody with me? Everybody with me? We got the relative velocity. So let's redraw the situation now. Let's redraw the situation. Pandu is over here. Champa is 30 meters away initially. Champa is 30 meters away initially. And this Champa begins to move relative to Pandu in this direction. That means like this. She'll start moving like this. Yeah. And with what speed will she move? I don't know, but this is the direction at least. This is the velocity of Champa with respect to Pandu. So if she continues moving in that same direction, she will keep going like this. But the closest will be when you drop a perpendicular. So I'll have to drop a perpendicular maybe over here. So this is when Champa will be closest to Pandu. Diagram clear? We have not yet found any value as of now. Diagram is absolutely clear. Okay, clear. Sir, how to solve this, sir? It was looking all good in theory, but when it comes to problems, and it looks good in theory, when it comes to problems, it becomes difficult. Okay, see, use logic, use the given information somehow. Maybe we need the angles, maybe we need the speeds. Can we figure out how much is the speed, VCP? I think so, bro. How much? This is Pythagoras, no? 8 square and 6 square. 64 and 36. 64 and 36 is 100. Root of 100 is 10. So 10 meters per second. So this speed is simply 10 meters per second. Such a good number. I feel even the angle will be good. Huh? I feel the angle. Oh, don't think the base of the triangle is 10. Sir, this is 30, this is 10. I can find this. Oh, no. See, this is meter. This is meters per second. Don't get confused. If you want, I will draw this little smaller only. Or else you guys know, you will get confused. Don't get confused between the two. This is velocity. This base is not really 10. If you really want to find the base, better find the angle. Can we find the angle? I think so. How? Think carefully. If I want to find this particular angle over here, can we really find that angle? Let's say I call it theta. Opposite side, adjacent side, yes, definitely. Tan theta is 8 by 6, which is 4 by 3. Oh, theta is nothing but 53 degrees. We got it. Theta is 53 degrees. So this angle over here is 53. If this is 53, this is 90. it is obvious this is 37 degrees. Step by step, we are proceeding. Step by step, slowly, 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 we are going ahead. Okay, perfect. Now what do we do, sir? Okay, all this is not needed. All this is not needed. This and all is done. Okay, now what do we do? See, if I want to find how much time will Champa take to go from here to here, if I know the speed, if I know the distance, my job is done. Yeah. So can we find this side length? Can we also find this length? Definitely. So if I want to find this small d, look at this right angle triangle. If I just use even sine 37, cos 37, so many things, like for example, sine of, or let's say cos of 37, cos of 37, adjacent side divided by hypotenuse. Cos 37, what is cos 37? 3 by 5 or 4 by 5? Cos 37 is 4 by 5, is d by 30. So 5 and 30 goes, by the way, 6 times. So it will be 4 multiplied by 6. So that will be 24 meters. So this is the closest distance of approach. This is the shortest distance between them while they were traveling. How many of you got it? Yeah, perfecto. How about the time taken to go from here to here? I will say, let me first find out this side, man. Okay, let me first figure out this side. How much is this side? Maybe we can do sine of 37. Sine of 37 is opposite side, which is, I don't know how much it is, and by hypotenuse, which is 30. Sine 37 is 3 by 4, is opposite side by 30 units. So opposite side is 4 goes with 30 2 times and it will become 15 maybe. 15 3s are 45, 45 by 2, that is 22.5 meters. Just check this out. Is it 22.5 meters, everyone? Yes, no? 22.5 meters. Come on, my dear students. Good to go? Darshan, perfect. All right. Now, this is distance, this is speed, time. That's it. So, relative speed. Last lecture only I gave you this. Relative speed is relative distance by relative time, or basically just time. So, here relative speed is 10. Relative speed is 10. Relative distance is 22.5. Relative time, I do not know. So, time will be 22.5 by 10, which is 2.25 seconds. So, in 2.25 seconds, Champa will be closest to Pandu. So, if you animate this diagram, what it means is Pandu will keep moving, Champa will also keep moving. So, their separations will keep changing like this. So, after some time, maybe Pandu will be here. After some time, maybe Pandu will be here, Champa will be here. Okay. After some time, Pandu will be here, Champa will be here. After some time, like this. After some time, maybe 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 like this. So this is how their distances are changing. This is how their distances are changing. You can see a beautiful, thing, curve or some nice pattern being formed. So after 2.25 seconds, maybe Pandu is here, Champa is here, and then that separation will be the closest. We could never have done this using this diagram, but this is just for you to visualize things. What was exactly happening in this? So, is this clear, my dear students? Did I use 4 by 5 by any chance? 3 by, ayyo, what did I just do, yaar? I'm so sorry, guys. That was such a blunder. So sorry. Thank you so much for pointing it out. That was my mistake. My mistake. Sine 37 should have been 3 by 5, not 3 by 4. I don't know why I said 3 by 4. It is 3 by 5. So sorry. Opposite side by 30. So opposite side. 5 goes with 36 times 6 3s are 18. So will it be 18 meters? Does that make sense? Okay. Yes. And then if I use relative speed, is a relative distance by the time, last time's concept. Speed is 10, distance is 18, time I do not know, so time will be 1.8 seconds. Is that now okay? Yep. Yes, Mohammed, correct. How do you find such angles, sine, cos? Okay, there is a trick to remember, and the trick is this particular right angle triangle, which is a Pythagorean triplet. 3 square plus 4 square is 5 square. This is side 3, this is side 4, this is 5. This is a very special triangle. And you can also get a similar triangle to that. You can also get a similar triangle to that, which is slightly bigger, like this. This will be a similar triangle, I believe. And that would be 6, 8, and 10. Even 6 square plus 8 square is 10 square, and you can get many more such Pythagorean triplets. The speciality is that, see, do you see this number 5 and 3? Do you see this number 5 and 3? The shortcut is put this 5 and 3 together. This angle will be 53 degrees. Now don't say, sir, 4 and 5 together will be 45 degrees. No, this was just the trick to remember which angle is 53. Automatically the other angle will become 37 degrees. So now you can find sine, cos, tan, cot, whatever, sec, cosec of anything. So this is a special angles triangle. Okay, Darshan? Clear, Sabri. Oh, some. Perfect. All right. So this is also done. Now let's do one more killer question in 3 dimension, of course. Oh, sorry, 2 dimension. And then we will slowly go on to some more 1D questions of approach and separation. Now this is also asked in previous year JEE paper. This is also there as a H.C. Verma solved example, and also in exercise of H.C. Verma. And this is one of the most brilliant questions, I would say. So imagine there are 3 animals, maybe 3 dogs or whatever, and they are separated by some distance. Let's say I call it A. And they are on the vertices, the dogs or those animals are on the vertices of the triangle, equilateral triangle. What these dogs begin to do is they begin to move towards the next dog, and wherever that next dog is, they start moving towards that dog. That's very interesting. So this dog will move towards this dog. This dog will move towards this dog. This dog is instructed, you just chase the next dog, all of them with the same speeds v. Now in this process, what will happen? These dogs slowly will start coming close to each other, and they will all meet together at the centroid. How does that happen? Let's think. Because these dogs are chasing each other, so maybe after some time, because this dog is instructed to chase this dog, this is moving here. So just think about it. It was going like this. This dog will be over here. So this can't be directed at the same place. This has to change the direction. As this dog goes here, this has to change here. And do not forget, this dog changing direction also means this dog, which was going here, should also change the direction slowly. And this dog changing the direction also means this dog can't go in straight line. This dog also has to keep changing the direction. And all of this is happening simultaneously. So it also means that most likely the dogs will go in a curved path, maybe something like this. The dogs will go in a curved path, something like this. Does that make sense? They'll all go in a curved path. Yeah? So visualize this. This dog was going here, will go like this, will go like this, will go like this. Reason being, this dog over here, which was supposed to go over here, is going like this, and then going like this, and then going like this. Every time it was just directing its velocity towards that particular dog. It was just directing its velocity towards that particular dog. That is how it is going in a curved path. finally when they meet, yeah, like a loop, yes, but they will meet. It's not like it's an infinite loop. Sir, they will go like this, like this, like this, like this, like this, like this. Sir, will it become like approaching to zero but never becoming zero? No, no, no. It is not like that. They will eventually meet. So they will definitely meet at the centroid. They will definitely meet at the centroid. The same question is also there in HC Verma in exercise, but then what they do is they give a square diagram, and then they tell instead of 3 dogs there are 4 dogs. There are 4 dogs, and each dog is approaching the next dog like this with the same speed. Each dog is approaching the next dog with the same speed. When will they meet? That is the question. And then there is another question where they have given hexagon. What have they given? They have given hexagon. So,
I'm Siri, your virtual assistant.
thank you so much for reminding me that you are my virtual assistant. Can I just... No? How to do this, man? Okay. Okay. And then they give basically a hexagon, and there are 6 dogs all chasing each other, and when will they meet? If you are able to solve the triangle question, you will be able to solve the square, pentagon, hexagon, octagon, whatever gun. Okay, Murugan, everything you will be able to solve. Okay, everyone? Yeah. So how will this diagram look like after some time? Again, if you see their motion, it will look something like this. They will all go meet over here. They will all go meet over here. They will all go meet somewhere over here, like this. Same thing for even for this hexagon as well. Okay, even for this hexagon also, it will look something like this. They will all meet at the center. Here they will meet. This is how the diagrams will look like. So how to solve these questions? That is the main problem now. Okay, let's see. Okay. See, this is a question of relative velocity. You should understand that first. Why is it even in this chapter? Why is it not some other concept? Reason is the dogs are slowly coming close to each other. They are approaching each other. The moment this word approach comes, the concept of relative motion also comes. Yes or no? Agree or disagree? That is why it is a concept of relative motion. The dogs were far, and now their distance slowly becomes 0. Got it? Okay. That is why. See, you should think, what will you think in the exam? Because how will you know in the exam that it is a concept of relative? Now I'm teaching relative, so that's why all questions are relative. But in the exam, it should click, no? Okay. So maybe I don't have to juggle around all the dogs. I just need 2 dogs. Because if any 2 dogs meet, it is obvious that all the dogs have met. Yes or no? If 2 dogs meet, whether it is a triangle, square, or a hexagon, if this dog has met this dog, it is obvious that the other dogs also have met. So my problem is no longer of all the 6 dogs or the 4 dogs or the 3 dogs. It is just of 2 dogs. So focus your attention on 2 dogs. See how I'm reducing the problem. Complex question, slowly getting rid of unnecessary information, simplifying it. Okay, I just need 2 dogs. So let me take the base. It's easier to solve maybe. So observe now. This particular dog versus this particular dog. This dog is going like this with speed v. This dog is going like this with speed v. Also, I need to tell you that, hey, listen, there is some separation between them. And of course, this angle is 60 degrees because of equilateral triangle. This is the relative distance which is slowly, gradually changing. This is the relative separation between them. Relative separation between them. And not just that, I notice one more thing. As the dogs come closer and closer, believe me, you will get smaller and smaller triangles. Like this. Every single time. Yeah, it will always be a triangle. It's little difficult for me to show, but just try and understand it. They will always be the same shape, that the shape will become smaller and smaller. Same thing also is true for square. It will always be a square only. It's just that the square will slowly become smaller and smaller. The square will just become smaller and smaller. Okay, the square will just become smaller and smaller, which means at every single point of time, this velocity with respect to this dog will always make 60 degrees. So 60 degrees, that angle is a constant. It is not changing. Did you appreciate this? This is a very important part. I hated my relative, but this relative is very good. I agree. Oh, so what, sir? So what if the angle is constant? Okay, I'll tell you what. Resolve this velocity into two components. Yeah, resolve this velocity into two components. One component over here, which is v cos 60, which is v by 2. And this component over here, which is v sine 60, which is v root 3 by 2. So what now? What do I do with these components? I say, ignore this component because it is not affecting the relative separation because it is perpendicular. So the sine component is perpendicular to the relative distance. It is not really affecting that distance of separation. It is this component which is making this dog come closer to this. So can you tell me what is the relative speed of approach between the dogs? Forget these. Just look at v by 2 and v. Opposite direction. V by 2 from here, v from here, approaching with what speed? Tell me in the chat box right away, right now. What is the relative speed of approach? Everyone. Yeah, it is just going to be v plus v by 2. Correct. 3v by 2. Amazing, guys. 3v by 2. Get it? Forget this. This is of no use now. No use. V by 2 here, v here. Two cars going with opposite directions. 3v by 2. Oh, relative separation. What was it? Initial separation. Initial separation was a. Finally, it is 0. So what is the relative distance which they have traveled? The separation was a. Slowly it becomes 0. So relative distance is a. So can we now figure out the time? Obviously, speed is distance by time. So time is how much? A into 2. So 2a divided by 3v. That is the answer. 2a by 3v. Such a simple thing, but the concept is so good. This came in JEE. Loved it? Perfecto. Amazing. Cool. Yeah. Now, can we also solve for the square? Can we also solve for the square, guys? I think it should be easy now to solve for the square. Our focus should be only on the two dogs, any two dogs. Maybe this dog and this dog, and there is some separation between them. This dog is going with some speed of v. This dog will always go with the speed of v, and this angle will always be 90. Best part, this velocity I need not resolve. It's already perpendicular, so it's useless. This velocity will not affect separation at all. This will not affect separation at all. So can you tell me what is the relative speed of approach? Relative speed of approach. Quickly think and tell me. Yes, the relative speed of approach is v. What is the relative distance that they travel? This was a, it will become 0. Relative distance was a. Relative speed is relative distance by time. So time is v by a. Sorry, a by v. That's it. Direct answer. Direct answer. Very easy it is to solve. For homework, can you solve the hexagon question? This is your homework. This is your homework. I want everybody to answer it in the Telegram group. Okay, our discussion group is there. If you're not yet a part of it, please be a part of it. And everybody is going to post the solution, not just the answer, because the answer you can find it everywhere. I want your handwritten solution. Okay, I want your handwritten solution in the Telegram group. Everybody post it. All right, fair enough. I'll be checking it out by tonight or maximum tomorrow morning. Great. Now, imagine I ask you, can I use kinematic equations in the relative frame of reference? The answer to that is yes. So can I use kinematic equations in a relative frame? Okay, can I use kinematic equations in a relative frame? The answer to that is yes, meaning I can say the relative velocity is finally is relative initial velocity plus the relative initial acceleration. Also, I can say relative displacement is relative initial velocity into time plus half into relative acceleration into t square. Same thing, final speed relatively square is initial relative speed square plus 2 times relative acceleration into displacement relative. All of them are still valid, just that relative. But please bear in mind, these are only applicable under a condition. Can you guys guess that condition? There is one basic condition for them to apply. The relative acceleration must be a constant. Just like for applying kinematic equations, acceleration must be constant, your relative acceleration must be constant. Number one. Not just that, number two is that all the relative motion must be observed from the same frame of reference. Same frame of reference. And it makes sense. It's like very obvious. How can I measure acceleration from ground frame, velocity from Jupiter frame, and displacement from lift frame? Then the equation will not make sense. How can we put such things? If I'm measuring from the lift perspective, everything should be from lift perspective. If I'm measuring with respect to the car, everything with respect to the car. So that is one thing which you should be aware of. Clear, everyone? So these equations are definitely valid, just that these conditions have to be obeyed. Otherwise, there is no point. Yeah. Yes. So maybe we'll solve some questions and then we'll get a hang of it. Say for example, there is a thief and he was at maybe he was already in motion, maybe at a speed of 10 meters per second, and he's slowly accelerating at 1 meters per second square, like this. And then there is some police over here. There is some police over here. He sees the thief. He starts from rest but begins to accelerate at 3 meters per second square. There is some separation between them, maybe 20 meters when this is seen. So it's like the thief has stolen something. He starts running. By the time the police realizes, okay, I have to catch him. By chance, the police was there. Already the thief has crossed 20 meters. He has already achieved some speed, 10 meters per second, and he's also accelerating. So the police also starts from rest and begins to accelerate at 3 meters per second square. Question is simple. When will the thief catch the police? When will you catch? That's the question. Okay. Do you think we can solve this by relative motion? Yes or no? Think about it. Can we solve this by relative motion? Yes, makes sense. We should be able to solve. So if you look at it from the ground perspective, I mean, the thief might be traveling so much. The thief might be traveling so much. The police might be traveling so much. Eventually, before they are caught. Before they are caught. And there is some kind of initial separation like we mentioned over here, which is 20 meters. So we can be on the thief, we can be on the police frame of reference. Anything is fine. Anything is fine. So we choose any frame of reference. So let's decide on something. Maybe we decide on the police frame. So if you are on the police frame of reference, which is this guy over here, let's think what and all will we see the thief doing. Let's see what and all will we see the thief doing. Everything, literally everything. So velocity initially of the thief with respect to the police is velocity of the thief minus velocity of the police. Velocity of the thief is 10. Velocity of the police 0 because at rest. So it will be 10 meters per second initially. Acceleration of the thief with respect to the police is AT minus AP. Acceleration of the thief minus acceleration of police. So acceleration of thief is 1. Acceleration of police is positive 3. So 1 minus 3 is minus 2 meters per second square. Notice how I'm taking care of the sign conventions. Else I will be really messed up in the equations. Signs are important. I'm not visualizing much. It's like direct formula. UTP is UT minus UP. ATP is AT minus AP. Just that's it. How much you missed? I don't know, Darshan, when you lost the network, but we have just given this question as homework and we solved the square question also. Okay, we solved the square question also, and I just gave you the relative equations of kinematics, and it's the same thing. And then we are just doing this police and thief question. Okay. Now, what else do you think I will need? I need time. I have initial velocity. I have acceleration. What else do you think I will need? Think about the kinematic equations. Do I need the final relative velocity? Or do I need the displacement? What do you think I need? Yes, I do need the what? Correct. Displacement relative. Because then I can use the second equation, S is ut plus half at square. So what is the displacement of the thief as seen by the police? It's the displacement of the thief minus displacement of the police. You can think of it like that or just visualize it. Displacement of the thief for the police. The thief is in the front. The police is behind. What will the police see? The thief is here, slowly comes close, and I catch him. The thief is here. He's coming here. So the thief is going this way. What is this direction? Negative. How much was this distance? 20. So how much has the thief moved? 20, but in the left side. So wouldn't that be minus 20 meters? Just check this out, everyone. Is this minus 20 meters? Everyone with me on this? Correct? How many of you are able to visualize? Yeah, displacement between them will be 20 meters, but on the negative side. So now we have to just use the kinematic equations. So kinematic equation will be displacement is initial velocity plus into time plus half into acceleration into t square. This is minus 20. This is 10 multiplied by t plus half into acceleration is minus 2 into t square. Okay, perfect. So 2 cancels. I can see minus 20 is equal to 10t minus t square. So bring t square over here. So t square minus 10t minus 20 is equal to 0. Can I factorize this by some method? I don't think so. I have to use our quadratic formula maybe. So t is minus of b, which is minus 10, plus or minus root of b square, which is 10 square, minus 4 into a, which is 1, into c, which is minus 20. Whole thing divided by 2 into a. A is basically 1. Okay. So what am I getting? Therefore, t is equal to minus minus is plus, plus minus is there, 2 is also there. 10 square is 100, minus minus is plus, 4 into 20 is 80, 100 plus 80 is root 180. So now root of 180, well, I can take divisible by 4, obviously. Yeah, 45 into 4 is basically 180. Yeah, everyone? So it will be 10 plus minus 4 into 45. 45 is 9 into 5 again. Everything in perfect square form. So 4 comes outside as 2 and 9 comes outside as 3, and we have root of 5 over here divided by 2, divisible by 2, of course. So 10 by 2 is 5 plus minus 3 root 5. Now 3 root 5 will be more than 5. Yeah, 3 root 5 will be more than 5 because root 5 will be more than 2. So we can't have time as negative. So the only allowed value will be positive. So 5 plus 3 root of 5. That is what will be allowed, because 5 minus 3 root 5 is negative, which is not possible. Time can't be negative. So hence, this is our final answer. This is the time after which the police will catch the thief. Lovely question, guys. Did you like this question? Yes or no? Yeah, perfect. Amazing. So these kind of questions can also come. All right. Let's do another question coming up on your screen. Again in one dimension. Okay. So catching problems with relative displacement, relative velocity can come. Another kinematic question only we can do. There is a Champa. She is going like this with a constant speed of 20 meters per second. There is a Pandu who was initially going this way at maybe 40 meters per second. But as soon as he crosses Champa was going like this, Pandu was going like this. Pandu changes his mood and he begins to stop, decelerate, and he turns and begins to chase Champa. Visualize this. Okay, visualize this. Very, very, very freaky incident. Champa is here, then Pandu is over here. Pandu goes like this, stops, and then turns and goes like this. Meanwhile, Champa, she is unaware, she is going with a constant speed. Eventually, Pandu makes up and he will reach Champa and ask her something. I don't know what he's going to ask. Wow. So the question is, when will they meet? When will they basically meet? That is the first question. Second question, their separation will keep changing. So when is their farthest separation? When is their farthest separation? That is the second question. Understood, guys? These are the two questions that we have to solve. Farthest separation and when will they eventually meet? Okay, let's think carefully. Oh, by the way, there was one piece of information which I did not give only. What is the acceleration and retardation of Pandu? So acceleration or retardation of Pandu, acceleration or retardation of this Pandu is, example, maybe I'll take 5 meters per second square. Chumma, I have given something. Okay, that is the only thing which was missing, so I give that also. Maybe we should solve it sitting on someone, make somebody the frame of reference. Who do you want to sit on, Pandu or Champa? Anything is fine, guys. Doesn't matter. Pandu or Champa, everybody spam the answer, guys, quickly. Where do you want to sit? Good to go, I know. Champa? I knew this. Everyone wants to sit on Champa. West fellows. Okay, fine, we'll sit on Champa. Champa is driving her scooty or something or some bike. So we are sitting double seat on Champa. So from Champa's perspective, let's observe what is happening. From Champa perspective, let's observe what exactly is this Pandu up to. What exactly is this Pandu up to? Okay. All this I will remove, not needed. All right. So what is the initial velocity of Pandu with respect to Champa? It is velocity of Pandu minus velocity of Champa. Velocity of Pandu 40. Velocity of Champa, be careful, negative 20, minus 20. So technically it is 60 meters per second and it is positive. That means towards the right side. Okay. It's surprising that everybody said Champa, nobody said Pandu. Okay. Then what is the acceleration of Pandu with respect to Champa? It is AP minus AC. Acceleration of Pandu, what it is? Acceleration of Pandu. Oh, first he's stopping and then accelerating. So during this journey, his retardation or acceleration will be this way, 5 meters per second square. After he stops, again he will accelerate this way only, 5 meters per second square. So always his acceleration was towards the left side. So acceleration of Pandu will be minus 5. Do you get it? Why it is negative 5? It's left side. Yeah. Oh, MD, you said Pandu, huh? Okay, fine, man. And acceleration of Champa. Oh my God, Champa is going with constant speed. So 0. So constant speed, so 0. So minus 5 meters per second square. Initial velocity, acceleration, both got. Now let's think. What do we exactly need to solve the question? First, we have to ask ourselves, when will they meet? So when they meet, what is so special? Think logically. When they meet, what is so special? You might say, sir, it is very special, sir. They are meeting. It's a very nice romantic thing. See, if you look at it relatively, initial velocity is like this. Acceleration is like this. So when velocity and acceleration are in opposite direction, means the velocity will keep reducing. It will become 0 and then it will reverse until you come back here. So when Pandu relatively, just imagine Champa is just going like this. She sees Pandu here. She sees just Pandu here. The Pandu goes there, stops, comes back. So relative to her, can you guess what is the displacement? Can you guess what is the relative displacement when they meet? So when they meet, there is a movie, Jab We Met. So like that only. When they meet, what is the relative displacement of Pandu with respect to Champa? If you can answer this, I would be very, very happy. Some people are saying 5, some people are saying 0, some people are saying don't know. Interesting. I'll tell you what. First, when Champa sees Pandu, Pandu is just beside her. Fine, he did some nonsense and came back. He's again besides her only, no? So the position did not change. Position did not change, which means what? Displacement is 0. Yes, answer is 0 meters. 0 meters. Got it? Yeah. Displacement. I'm not talking about distance at all. I'm talking about displacement. Relatively, that too. 0 displacement when they meet. Because first they crossed, they were at the same relative location. And once they again meet, again same relative location. So no change in the location. That is why 0 meters. This is now obvious which equation we have to use. First, second, or third. The first kinematic equation, the second kinematic equation, or the third kinematic equation. Which one should we use? Come on, think logically, guys. We have the answer now. We have the answer. Yep. Obviously, we have to use the second kinematic equation. So displacement of Pandu with respect to Champa is initial velocity of Pandu with respect to Champa into time plus half into acceleration of Pandu with respect to Champa into t square. Perfect. S is 0. UPC is 60 multiplied by t plus half into acceleration is minus 5 and this is t square. Perfect. T cancels. So 0 is equal to 60 minus 5 by 2 into t. Take this on this side. So 5 by 2 into t is basically 60. Okay. So 5 and 60 cancels. So t by 2, 60 by 5 is 12. So therefore t is 12 into 2, which is 24 seconds. Interesting. Just check it out. Understood? Clear? 24 seconds is the right answer. Got it? Loved the way we solved using relative concept. Just check. Everyone. So we found when did they exactly meet. But there is one part still remaining. When is their separation maximum? When is their separation maximum? Or what is that separation maximum between them? So for that, again think when the farthest distance of approach is there. I gave you at the start only. Farthest or closest distance of approach. What did I tell you? I told you right at the beginning. Farthest or closest. Relative velocity is 0. Did I not just tell you? When they are the farthest or closest, relative velocity is 0. So basically, that brings me when this Pandu is over here, this is when velocity of Pandu with respect to Champa is 0, and that is when you are the farthest. When you are the farthest from Champa. So obviously VPC is UPC plus APC into time. First kinematic equation. This is 0. This is 60. Acceleration is minus 5 into t. Therefore 5t is 60. Therefore t is 12 seconds. So after 12 seconds you will be the farthest. And if somebody asks how much is that distance, that we can figure it out using again S is ut plus half at t square. So SPC is UPC into t plus half APC into t square. I want to figure out that farthest distance. So that farthest separation between them. Farthest separation between them. Initial velocity 60, time 12 plus half into acceleration minus 5 and time again 12 square. So let's see how much will that displacement come out to be. Okay. 12 6 are 72. So 720 minus 12 square 144. 144 divided by 2 is 72. So 72 multiplied by 5. Guys, this is like saying this is 72 into 10 minus 72 into 5, which is nothing but 72 multiplied by 10 minus 5 only, which is 72 multiplied by 5. How much is 72 into 5? How much is 72 into 5? Yeah, you are getting 12 seconds. That is perfectly correct. 7 5s are 35, so 350. 2 5s are 10, so 360. So 360 meters. That is the farthest separation. Correct. That is the correct answer. Got it? So this is how relative motion concepts are. Okay. Let's do one last question. Let's do one last question, which will be very killer question. Ready for it, guys? Okay. All these are one-dimension questions. We also done some two-dimensional questions today. Let's do one more question. Beautiful question this is. Imagine there is an apple and somebody throws that apple down with a speed of 10 meters per second. And then we have a mango which is thrown up with a speed of which is thrown up with a speed of 40 meters per second, and they both are one below the other, but what is their height difference? That is also given to me. Okay, maybe their height difference is 100 meters. Chumma some value I have taken. Somebody throws from below the mango, somebody throws from top the apple. Eventually, what will happen? They will meet. Eventually, you will see that this mango and this apple, they will meet or they will collide. Question is, what time will they collide with each other? When will they collide with each other? That is the question. Okay. Again, I feel collision, meeting, farthest separation, closest separation, when will this again come back? All these are again relative concepts. Okay. So maybe we have to look at a relative frame. All right. Let's look at relative frame. First of all, let me ask you simple thing. Can we find the relative acceleration between them? Acceleration of, let's say, mango with respect to apple. Acceleration of mango with respect to apple. Yeah, we can definitely. And let me choose something as positive and negative. Maybe we can choose upwards as positive and downwards as negative. Nothing wrong. Okay. It will be nothing but acceleration of mango minus acceleration of apple. What is the acceleration of mango? Anything. You can sit on mango, you can sit on apple, anything, doesn't matter. So anything which is thrown will always accelerate with g. So the acceleration is minus g. Minus acceleration of apple, that will be also minus g. Array. So minus g plus g, that will be 0. Oh my god, the acceleration of mango with respect to apple is 0. So there is no relative acceleration. This is very, very critical. There is no relative acceleration. What is the immediate reaction you got in your mind? The moment you heard this word, there is no relative acceleration. So there is no relative change in velocity. There is no relative. Actually, they are changing. You can see the speed will increase, here the speed will decrease and again turn back. But relatively, there is no change in velocity. So that means there is no relative change in velocity. Oh, this is like good. Speeds and velocities are constants. So what is the relative speed? Therefore, can we find what is the relative speed between them? This and this are going in opposite directions. Opposite means add. So 10 plus 40, which is 50 meters per second. Perfect. 50 meters per second. Perfect. Everyone? Okay. Now, if I know the relative speed, I also know the relative distance. What is the relative distance that they travel before they meet? They were 100 meters apart. Finally, they meet. So relative to each other, they have traveled 100 meters. This is like two buses. When will they hit? two things, when will they collide? Just like that. Okay, so therefore relative speed is relative distance divided by time. Relative speed is 50, relative distance is 100, time I don't know. So time is 100 by 50, which is 2 seconds. That's it. We have found the answer very quickly. So these kind of questions can be done within seconds because the relative acceleration is not there. So relative speed will be constant. And when speed is constant, it is going constant speed, distance, time, and speed. Simple formula. Cool? Understood? So many different applications of relative motion. Yeah, we have seen so many questions on relative motion today. And one question I have already given you as homework. Yeah, so we saw things like speeds of approaches, separation, when is it maximum, minimum, and how to find those times or distances while chasing or meeting or colliding, all those things, even in 1D and in 2 dimensions. So we'll just solve one more question on 1 dimension and then we'll go to the riverboat and the rainman questions. Yeah. Hi Santosh, I hope you guys have seen the previous classes already. In case you have missed it, hi Sanju, good evening, my dear warriors. Yeah. So turning on the chats to private, I can still see your chats. Yeah. So that we are focused on the lecture. Cool. So let's say we do a question on lift, and these lift questions are also amazing. Last time we did a question on projectile motion, 1D projectile, where mango and some apple were thrown and when will they meet and stuff like that. I think that was our last question. Yeah. So we'll do a similar kind of question but related to the lift concept. So imagine that you have a lift like this, and what happens is there is a object which is stuck to the wall, okay, sorry, not wall, the ceiling of that lift, and it breaks off and it falls. So as it falls, it will hit after some time the flooring of the lift. Okay, it is mentioned to you that the lift was going up with some acceleration of 2 meters per second square, and the height of the lift, the height of that particular lift is given to be 4 meters. Okay, this is that question. So what we have to find is the time for the object that breaks off to hit the floor, that is one question, to hit the floor. Not just that, we have to also figure out what is the acceleration of the object as seen by a ground observer. Also find the ground distance traveled, the ground relative distance traveled. What is the ground relative distance traveled? If the lift had a speed, of 10 meters per second upwards when it broke off. These are the 3 questions that we have to solve. Let's go through it again. One is, how much time will this take to fall here? Second is, what is that acceleration when you see it from the ground frame? Third one is, how much distance will this travel if you look at it from the ground frame of reference? If when it was going up and it broke off, that time the lift had an upward velocity of 10 meters per second. Okay, so let's do one by one. Out of these 3 questions, which one do you suggest we solve first? I think one of these questions, if you solve first, then the second will be easy, then the third will be solvable. I think we have to figure out which order to solve this. Can you guys quickly guess which of these should we solve first? Yeah, come on, think about it. Yeah, what do you think? Yep, the third one, find the ground distance. Ground distance, well, we can do that, but do you know how much time was it in air? How much time was it in air? I don't know that. In fact, for that, I need to find that time. So I don't think we can solve that. So to find that time, I think we need to get the second one. Think about it, because if you know the acceleration of that object, and if you know the acceleration of the lift, then we can solve it using relative motion. And relative motion, that means inside the lift frame of reference, how much is the displacement, how much is the acceleration, we can find the time. So in order to convert it into a lift frame, I would need the acceleration of that thing. So tell me one thing, once that object is free, okay, once that particular object is free from the ceiling of the lift and it is falling down, as it falls down, tell me one thing, will it be experiencing any other force apart from gravity? Think, once it leaves that lift ceiling, there is nobody touching it, nobody pulling, pushing it, only gravitational pull is there. So if only gravitational pull is there, what should be the acceleration of that particular object? That acceleration should obviously be equal to g downwards. Do you understand it? Yes, Pranav, 2, 1, 3. That's the right order to solve this. So often when multiple choice questions or multiple questions in a passage, or maybe multiple options are there in some another match the following, you need to always think sometimes which is the right order to proceed the question. Yeah. So acceleration is g, and the reason for that is since only gravitational pull is existing. Only gravitational pull is existing. So now let's also decide who is positive, who is negative. So let's go down, and because everything is going down as positive and anything going up is, let's say, for example, negative. So let's start off with the first part over here. So what will be the acceleration of that object with respect to the lift? It's acceleration of the object minus acceleration of the lift. Object is going down with the g acceleration, that means it is plus 10, okay, and it is plus 10 because it is positive, whereas the lift is going up, so it should have negative acceleration. As per the sign convention, it is going up, so that's why negative acceleration. So 10 minus minus means plus, so 10 plus 2 is 12 meters per second square. That is the acceleration of the object with respect to the lift. Everyone? Yeah, we'll take 10, not 9.8, because 10 is a good number. Okay, Tejaswini? Fine. Now think like this. What else we need? I think we know the initial velocity of the object with respect to the lift as well. How? Because it broke off from the lift. It broke off from the ceiling of the lift. That means as the lift was going, it was going, but at some instant it left. So it started with 0 speed. Just think, there is a object stuck on the ceiling and it breaks off contact. So initially it had no speed, not from the ground frame, but from the lift frame. So that is why this is 0. This is since it drops with respect to the ceiling, with respect to the lift ceiling. That is the reason for it. Lot of students miss this information. A small word can be an equation. A small word can be an information. So you cannot ignore anything in the question diagram. Things are hidden. Okay? Read between the lines. Next important thing. I think I know how much has it moved. If I'm in the lift and I see the object hanging there and it breaks off and it comes down, so for me, it has dropped down by some amount. So there is also the displacement factor, which I know. So displacement of the object with respect to the lift, it's going down by 4 meters positively. So it is 4 meters and plus sign. Everything is relative to the lift. Displacement, speed, acceleration, time, I don't know. So obviously the second kinematic equation. So let's use that. Displacement of the object with respect to the lift is initial velocity of the object with respect to the lift into t plus half times acceleration of the object with respect to the lift into t square. Okay, so displacement is 4, initial velocity is 0, acceleration of the object with respect to the lift is basically 12, and here we have 2 square, t square. So this 4 will become 12 by 2 is nothing but 6 t square. Therefore, t square will become 4 by 6, which is nothing but 2 by 3. Therefore, the value of the time is root of 2 by 3 seconds. So after root of 2 by 3 seconds, this object which breaks off will hit the floor of that lift. That is the answer. Everyone, give me a thumbs up in the chat box. I can see it. Yes. Root of 2 by 3. Sabri. Yeah. Root of 2 by 3. Yeah. Yeah. Perfect. Everyone. Yes. So t square is 2 by 3. Okay. So that's why it is 2 by 3. Not root. Sabri, why are you saying that the root will not be there? Did we miss anything? Displacement is 4, initial speed is 0, acceleration is 12, 12 by 2 is 6, 6 t square, 6 will go on below 4 by 6, which is 2 by 3, so that is t square, so t will be root 2 by 3. Just see. Sabri, I think you made a mistake or something. Yeah, Anita, everyone fine. Pranav, Zisha, Ayan. All right, Hari. Okay, yeah. Fair enough. So that was the first part. Now let's go to the second part of the problem. Oh, sorry. I think that was the second part and the first part. So time, we figured it out. Even this we know, acceleration of the object as seen by the ground observer. Acceleration as seen by the ground observer is just g. So this part is also done. Okay, nothing left in the first two. Okay, so acceleration is g, no other gravitational pull. This was from the ground frame, of course, and time also we figured out. So now the only thing remaining is the third part, find the ground distance traveled. Okay, so let's see how much is the ground distance traveled. Now for that, because everything has to be figured out from the ground frame, we know the acceleration of the object from the ground frame is just 10 meters per second square. Is just 10 meters per second square. Okay, it's downwards. But initial velocity of the object, because it is clearly mentioned over here, it is 10 meters per second, but upwards. So whatever is the lift speed, whatever is the speed of the lift will also be the speed of the object. So, you know, you have to think of it like that. If this was the ceiling of the lift was going up at 10 meters per second. It is natural that this object was also going up at that time at 10 meters per second. So this was all at t is equal to 0 initially, just when it broke off. Okay, perfect. So sir, initial velocity you are saying it is minus 10 meters per second? Exactly, it is minus 10 meters per second. Okay, now the question is to find that displacement distance, whatever. I think question asked is on ground distance traveled. So I have a problem the moment I see speed and acceleration being opposite in sign. So, you know, things are going to retard and all of that. So we need to be little bit careful about it. See, what it means is that, you know, this particular object had a speed upwards, but acceleration was downwards. So it will go up and then it will come down like this. So I don't know whether it will stop by root 2 by 3 seconds or not, because the root 2 by 3 seconds it's going to hit the floor. So when it hits the floor, is it still in its upward journey or is it in its downward journey? That's going to matter. Because if I use S is ut plus half at square, it will be displacement, not distance. And question is distance, not displacement. So by chance, if root 2 by 3 is somewhere here, time, then this distance and this distance needs to be added separately. Else we will be in a soup. How many of you understood the catch in the problem? Why it is important to figure out whether it stops before 2 by 3 or after root of 2 by 3 seconds. Okay? Else distance and displacements both will be completely different. Okay. So let's just figure out when does it stop over here. When does it stop over here? So using V is equal to U plus A into T, velocity is 0, initial speed is minus 10, acceleration is plus 10, and time is over here. So therefore 10t is equal to 10, therefore t is equal to 1 second. Now if time is 1 second over here, before it reaches on the top, it has hit the bottom. It has hit the bottom of that lift, because root 2 by 3 is obviously less than 1. This is definitely lesser than 1 second. So it means, what this means is that it hits the object hits the floor of the lift before reaching the top, before reaching the top. So root 2 by 3 will be somewhere over here. So that time which we are referring to, root of 2 by 3 will be somewhere here. So in this case, won't the distance and displacement be equal? Yes or no, guys? So we are safe now. So the distance traveled will also be the displacement's magnitude, whatever, because you have not turned around. And we can use ut plus half at square magnitude. So initial velocity, well, that is given to be minus 10. Time, it is the root of 2 by 3 plus half into acceleration is downwards, we are taking as positive, which is plus 10, and time, which is again root of 2 by 3 but the square. So the entire thing's modulus. So what is this going to be? Well, this will become nothing but minus 10 root of 2 by 3. 10 by 2 is nothing but 5, and root of 2 square is basically 2, and this is basically 3. So this will just become minus 10 root of 2 by 3 plus 5 2s are 10. So again 10 by 3 over here. Now if you notice, 10 is there on the numerator side, here root 3 is there. So this is basically, if you just try to rationalize it, things will be little bit more clearer. Maybe I'll put it on the other side. Next slide, sorry. So this will be nothing but minus 10 root 2 into root 3 divided by 3 plus 10, okay, plus 10 by 3, plus 10 by 3. Okay, it's better to rationalize. So what and all is common? 10 by 3 is common, and I'm left with 1 minus, so here it is nothing but just root of 6. 1 minus root of 6. Obviously 10 by 3 is a positive number, 1 minus root 6 is a negative number. So because it's a mod symbol, so you need to be little bit careful. So it will be 10 by 3 root 6 minus 1. Reason, root 6 is more than 1. So obviously to preserve the positivity, so we need to put it as root 6 minus 1. So this is basically the distance traveled in meters. 10 by 3 root 6 minus 1. Clear? Yeah. So this was a very good question, because we needed to analyze whether it stops before it hits or after it hits. And once we understood it is before, so I just find out the displacement magnitude, which will be the distance. If it by chance didn't, then I'll have to find this separately and that remaining part separately, and those two distances I'll have to numerically add. So that will be a lengthier problem. But anyways, you know how to solve it. It's at the end of the day kinematic equations. I have put the mod symbol also because I know distance is always positive. So to keep it positive, I put the mod symbol. Okay. So Vedika, in the previous or in the last question, what just happened, I'll tell you. See, when it breaks off and it falls, with respect to the lift, it only falls by 4 meters. Okay. But remember that lift was already going up. So at 10 meters per second. So actual motion of that object will be first going up slightly and then it hits. But I don't know whether it is going up and then only it touches the floor, or while it is going up, it stops and then while coming down, it hits the floor. So to figure that out, we just figured out when does it exactly stop as seen by the ground. So I saw it stops at 1 second. I saw the velocity becomes 0 at 1 second. That means it hit the floor long time back. It has hit the floor long time back even before it reverses the direction. Okay, it is still going up. So as it breaks off, it is still going up and it hits the floor of the lift. So you know the distance and displacements are equal. So displacement formula ut plus half at square, kinematic equation, initial speed and acceleration, and the time, obviously only the falling time you have to take. Don't take 1 second because 1 second means it is more time. It will fall off at root 2 by 3 only. So substitute, rest is calculation. This is simple calculation. Okay, fair enough, crystal clear. Okay, great. What a lovely question, guys, this was. Now let's do, because it is a rainy season, let's do this next type of question, which is rain man problems. Okay, so we have done a lot of questions on 1D relative. 2D also we solved last lecture. Let's do some more questions on 2-dimensional. So these are basically rain man questions, rain man problems. See, in these kind of questions, what happens is you will be given a task of holding the stick of the umbrella, and you have to hold the stick of the umbrella in such a way that you do not get wet or you get least wet. So whosoever that person is who is holding that umbrella should get least wet. That means for him, the rain, whatever direction it falls, if he holds the stick of the umbrella along the direction of the rain, then that person will be least wet. So that logic is holding the stick of the umbrella in the relative motion direction of the rain, so that what happens, the person is least wet or is relatively dry. That is the concept. And you will realize this because if you start moving, then your perceived direction of the rain will change, right? You might have seen this, especially while moving in an aeroplane or in a bus which is fast. You will see the drops of the rain start making different angles as the speed of the bus or that vehicle changes. So we need relative motion of the rain. So the logic is we need relative motion of the rain. That means velocity of the rain with respect to that person or that man who is traveling. So this velocity of the rain with respect to the man is nothing but V12 is V1 minus V2. So it will be velocity of the rain, but you have to make velocity of the man negative. Velocity of the man negative. So say for example, this person over here, okay, was traveling like this. So this is the velocity of that person, and maybe it was given to you listen the rain was maybe like this, the rain is like this. Now the rain is like this, that means this is the actual direction in which rain is coming. So this is actual with respect to the ground frame. So if you are stationary, this is how the rain will appear to come for you. So using this particular equation, VRM is VR minus VM. So you have to take the negative vector of VM. That is very obvious. So I will take negative vector of VM. So maybe this is negative VM. So I'll put this over here. This is minus VM. And we also need VR vector. VR vector is the rain vector. So maybe the rain vector is coming like this. Okay, just I'm putting over here. This is VR vector. So this is first vector, this is second vector. First vector plus second vector. Remember, vector subtraction is like adding a negative of a vector. So use triangle law of vector addition and you will immediately get this particular thing. So this over here is nothing but VRM. So this person will have to hold the umbrella along this green line. If he holds the stick of the umbrella like this, then he will be least wet. Understood, guys? Is this absolutely clear? It's at the end of the day, only this equation. Do not by heart any other formula. Just VRM. And VRM, by logic, you know, it is VR minus VM. So only have to negate velocity of the person. That's it. Got it, everyone? Okay. So let's do a question so that you guys get a hang of it. Example. Let's say this is a road, okay, and it is given to us that rain is maybe falling like this. Rain is falling like this, and the rain is falling making angle of, example, 53 degrees. So the speed of the rain is given to be 10 meters per second, and let's say it is also mentioned this particular direction is east direction and this direction is west direction. Now imagine it's told that there is a person who basically is walking, and his walking speed is, example, maybe 9 meters per second. Okay, maybe 9 meters per second. Okay, just some random value I have taken. Question is, find the direction of umbrella in the first case when as he's walking the first case towards the east, and in the second case that same person is walking towards the west. So in both the cases we need to figure out which direction should he hold the umbrella. Okay, that's the question. Let's do it step by step. Don't force yourself suddenly that within 1 second you should get the answer. Nothing like that. Go step by step logically. You think we need relative velocity, that is very obvious. So let's write down our governing equation, which is VRM, velocity of the rain with respect to the man, is nothing but velocity of the rain minus velocity of the man. This is our governing equation, the main equation which we'll need. Okay, for both the cases. Let's take the first case, which is the east case, and then we will solve it for the west case. Okay, first let's look for the east direction. If the person is going towards the east direction, VM is very obvious that will be like this. So VM will be like this, and the vector's magnitude, because he goes at 9 meters per second, it will be like this. But for solving, we'll need negative VM. Do not forget that. So negative VM means we need it to be like this. Okay, so this is negative VM. Magnitude wise, obviously it is still going to be the same only, nothing different. It will still be 9 meters per second. Okay. Now let's draw speed of the rain. It's 10, but at an angle. Now I have an idea over here that since that is a known angle to me, see, yes, 10 meters per second will be like this. 10 meters per second will be like this. VR minus Vm is VR plus negative Vm. So technically, I will have to put this over here like this, maybe. I'll have to put it like this. Okay. Now observe carefully, guys. This is your VR vector. Okay. The missing side of the triangle, which is this one, will be your VRM. Oh, at least the vector part is done. At least the vector part is done. When the rain is falling like this, I know it will have two components. Can you guess those components right over here? Yes, this will definitely have two components. Can you guess those components is the question. Just think carefully. This VR is having a side length of 10 meters per second. This angle is given to be 53 degrees. What is the base? What is the height? This will be 10 cos 53. Cos 53, how much is it? Cos of 53. Recollect our special triangle and you will get it. Recollect our special triangle and you will definitely get it, guys. Just check it out. Will it not be 4 by 5? Just check it. Will it be 4 by 5? That means it will be basically 8 meters per second. And this height will be 10 sine of 53 degrees, which is 10 sine 53 will be 3 by 5, which means 6 meters per second. That is the height and the base of that triangle if it is split into two parts, the components. Perfect. Sir, is Rainman problem plays a separate role in? Yes, definitely. There are many questions on Rainman questions. You open up previous year paper, you will see it. So I have an idea now. Let me draw the height by extending the triangle and the base. This base over here is basically 8 and this height over here is basically 6. So technically speaking, for that big triangle which you can see over here, can you tell me how much is the total base length? This much is 9, this much is 8. So it will be 9 plus 8, isn't it? Which is nothing but 17 meters per second. And the total height is nothing but 6 meters per second. The total height is nothing but 6 meters per second. Perfect. We got it. Cos 53 will be, did we miss it? One second. If this is 53, this is 5, this is 3, this is 4. Cos 53 will be 3 by 5. Did I write it as 4 by 5 by mistake? Oh, sorry guys. Then this will be also wrong. Sorry, then this will be also wrong. This will be wrong. This will be wrong. Okay. Thank you for pointing it out. By mistake, I think I took it as 4 by 5. Yeah, it should be 3 by 5. Perfect. This should be 3 by 5. That means it should be 6 meters per second. And this should be sine 53. Sine 53 is 4 by 5. Yes, this should be 4 by 5. So this should be 8 meters per second. Perfect. So if this height is 8, this will be also 8. And that means it will be 8 meters per second height wise. Base wise, this will be 9. And this is how much? 6. So it will be 9 plus 6, which is basically 15 meters per second. Just check this out. Now is it fine? Yep. Yeah, I think I just interchanged it. No, you are not at fault. You are correct. I made a mistake. Happens. Okay. Now the question is find the angle made by the stick of the umbrella. But usually with what direction is the angle given? It's completely up to the options. Sometimes they might ask what is the angle made by the stick of the umbrella with the horizontal. Sometimes they might ask it with the vertical also. Now since they have not mentioned here, maybe if the options were given, it would be more clear, but we can find any angle that we want. So say for example, usually they ask with vertical. So if this particular angle was asked, which is let's say theta, so then tan of theta, which is the opposite side, which is 15 divided by adjacent side, which is basically 8. So theta will be tan inverse of 15 by 8, but this is with vertical, with the vertical direction. So with the vertical direction, you will make this much angle. What is going to make that angle? The stick of the umbrella. So the stick of the umbrella. So the stick of that umbrella is going to make tan inverse of 15 by 8. Got it? How to solve this question? Let's do the next part. Now next part will be much easier because most of it is done for us. So Vm is west side. So Vm, velocity of the man, is this way. This is how the man is going, and his speed is given to be 9 meters per second. So negative Vm will be here. Negative Vm will be here. This is negative Vm. Magnitude wise, it is still going to be 9 meters per second. Rain velocity is still going to be like this. Rain velocity is still going to be like this. But you need to be careful, the base and the height components. Base is 6 and height is 8. Okay, so base is only 6. So that means most likely like this. So this is your VR, and in that, this much and this much, the base we just calculated here, it is 6. So this much is just 6 meters per second. This much is just 6 meters per second, and the height is 8 meters per second. So now let's complete the triangle. Yeah, so VR plus negative Vm. So complete the triangle. This is nothing but your VRM vector. This is your VRM vector. Okay. So the angle which is needed usually with the vertical, but you can also find with the horizontal. It's the same thing. Let's say call it theta. So for that, I need the height, I need the base. So height is very obvious. It is still 8 meters per second. But what about the base, guys? This is the base. So can you guess how much is the length of the base? This much is 9. This much is 6. So this much will be 9 minus 6, which is 3 meters per second. Only this much. 9 minus 6, which is 3 meters per second. Height is still going to be 8 only. Height is still going to be 8 only. No doubt about that. So we can easily now say that tan of theta is opposite side by adjacent side. So therefore, theta is tan inverse of 3 by 8. So this is with vertical. Again, with the vertical, if it was horizontal, it will be exactly opposite with the vertical. This is the angle which your stick should make. Done and dusted. Right. Yeah, the base is 3. Correct. Fair enough. Shall we go to another question then? Ready for it? Yeah. Ready for it, guys? Can we go ahead to another question? Okay. Here comes another question. A rain falling at 8√2 meters per second. Rain is falling at 8√2 meters per second. And at 45 degrees. And a person walking holds the umbrella vertically up. If he turns back with the same speed, find the angle made by the stick. That's the question. Beautiful question. Let's see one by one. There are two scenarios here. First scenario is normally walking, second scenario is turned back. So unless we solve the first scenario, we can't go to the next scenario. And in the first scenario, it is clearly mentioned that he is holding the umbrella up. That means out of VR vector, VM vector and VRM vector, which vector's direction is clearly told over here. He holds the umbrella vertically up. VR, VRM or VM. Who do you know precisely? How are you keeping these questions in your mind? I'm just making the questions on the spot, man. I'm not like remembering any question. It's just with the flow. Even when I started teaching, only first year I had one paper. After that, whatever I have been teaching, we just go with the flow. I make questions on the spot. Yeah. Yes, VRM. VRM, I know. Correct. Perfecto. So I know VRM because that's the relative positioning of the rain with respect to the person. It might be coming like this vertically down. That's the reason why he's holding the stick also vertically up. So basically I know VRM. Okay, so let's draw VRM first. Let's draw VRM first. Okay, rain is falling at 8√2 at 45 degrees. So we can take the rain falling in some direction, either this or this, doesn't matter. Here east and west, nothing is given as such. So maybe this is your VR vector. This is your VR vector. Magnitude wise, of course, it is 8√2 meters per second. And it is also mentioned it is falling at 45 degrees. Now, whether it is horizontal or vertical doesn't matter because it is, bisecting vertical and horizontal lines. So doesn't matter really. So where would be Vm now? Think logically. We know our governing equation is always VRM vector is our VR vector plus the negative Vm vector or minus the Vm vector. So to complete the triangle, obviously the negative Vm vector must be here. So this is negative Vm vector. That means the actual velocity of the person would have been here. So this is where the velocity of that man would have been actually. But I have to take minus Vm only for the equation's sake, for the solving purposes. Right? Yes, experience. So correct, Niranjano. All right. Now, from this triangle, I think we get a lot of information, guys, already. Yeah, how many of you can see it? Just see. I mean, this is already given to be 45 degrees. This side length is 8√2. I think we can easily guess how much the base of this particular triangle would be. The base will be 8√2 cos 45. Cos 45 is 1/√2. So basically 1/√2 and √2 will cancel. It will be 8 meters per second. And not just that, we can even find the height of this. Which will technically be VRM. So it will be 8√2 sine 45. Sine 45 is 1/√2. That means that will be also 8 meters per second. So this dude was going here. The rain was falling like this. And he found the rain to fall vertically down. So he held the stick like that. So this is the first scenario, the first line of the problem basically. Till this point clear? We have not yet solved the question, but till now we have just arrived at one step. Okay, till this full stop we have done. If it turns back, what happens? Think logically now, okay? We don't need this anymore. If it turns back, what do you think will happen? If it turns back, what do you think will happen? Yeah, things will change. VRM won't remain as it is. This won't stay there. Even this also, you need to be careful. See, instead of going this way, now he'll go this way. So this will be now Vm. This will be technically Vm. And this will be now minus Vm. Is it making sense? Earlier the dude was going here. Now he's turning back. That means this will be Vm. That will be negative Vm. Oh, great. But wait a minute, sir. I already know the height of this particular triangle which I have drawn over here, and this height was originally 8. So this is still going to be 8 meters per second. Nothing great. And the speed of the man, we already figured it out over here. If this length is 8, so obviously the speed of the man should also be 8 meters per second. So this technically is nothing but 8 meters per second. This is VR, this is negative VM. So where is VRM? By vector addition law, this should be VRM, yes or no? This technically should be VRM vector. Oh, got it, sir. This is the new direction in which the stick of the umbrella should be held like that, so that he gets least wet. But then, in order to find this particular angle which that stick of the umbrella is making, let's say call it theta, I think I will need the bigger triangle's dimension, and most likely I will go with tan of theta in this case, which is opposite side by adjacent side. Adjacent side we already know. The only problem is this entire thing. So can you see how much is this particular length? Can you guess how much is this particular length? If this is 8, this is also 8. So total will be 8 plus 8, which is 16 meters per second. Is that right? It will be 16 meters per second. Perfect. So I need to just put the number 16. So that is nothing but 2. Therefore, theta will be tan inverse of 2. That is the angle with respect to the vertical direction, which the stick will make. And this scenario is when he has turned around. When he has just turned around. So that's why I have reversed the VM. So when you solve the first part, only then you will get VM value, and only then you get the height of this triangle geometrically, which can be further used to find the angle when you use trigonometry. Without solving the first part, it was impossible to get to the answer. Got it? So like I said, at the end of the day, it is this equation, but you have to use geometry, some trigonometric formulas, maybe Pythagoras, whatever. Use your common sense. There is no direct no direct formula to solve. Okay, any Rainman formula, so use this formula, you'll get the answer. There is nothing like that. Perfect. Okay, so these are basically your typical Rainman questions. They are usually like this only. Okay, find the direction, or the direction is given and find the speed of the rain, things like that. Okay, so governing equation we have to use. Now let's go to the swimmer boat questions. That is the next type of question. So either it could be a river or it could be wind. It's one and the same thing. And it could be a boat or a swimmer. And if it is wind, it could be an airplane. So river or wind will be there, and if there is river, it will be with boat or swimmer. If there is wind, it will be aeroplane. Okay, so these kind of questions, how do we exactly solve them? River, boat, and aeroplane, wind. Okay, again here also there is a governing equation, and I'll tell you what that governing equation is. From that, it will be very, very laddu, very, very easy. Aeroplane, bird, anything, doesn't matter. All we can do is improve our thinking process and hope for the best. Definitely, Niranjan. I mean, let me tell you that if you're wondering, sir, you started creating your own questions only when you started teaching. That's not true, actually. No, birds are also there, Sabri. Which birds you want, you use that bird. Okay, parrot, eagle, crow, sparrow, whatever you want. Even when I used to prepare for my JEE, and it's not just me alone, but every student who is in IIT would be doing this in some way or the other, especially if physics is his or her strength, or I would say a good subject for that person, then 100% those kids would be playing with the questions. And when I say playing with the questions means, they think, what will happen if this happens? What will happen if this is not there? Why do we neglect this? What will happen if this is there? oh, it becomes non-solvable, or the mathematics does not support us to solve the problem at this stage in JEE level. So you should know why some things are forbidden, why some things are always like this, why some questions are always asked in this manner, what does the examiner want to check, and when that catch is being created or the trick is being played with you, why was it that you are not able to think the other way around, and how to create that trick, and can there be any more tricks, can there be any more situations where this might not be applicable, or suddenly this formula becomes applicable. Is this always going to be true, or are there exceptions? So this is the kind of thinking which students do when you are learning physics, especially if you want to make it your strength. And trust me, physics, obviously not because I'm a physics teacher, but you will see most of the toppers will always say either maths was their strength, and physics was their strength. Usually they will find chemistry a little bit difficult, but it again, we cannot generalize the crowd, but usually I've seen toppers saying that. Some students and some toppers have also told chemistry was their strength and physics was not their strength or whatever. But maths though is common. Maths should be your scoring subject. Yeah, at least moderately, maybe not the fullest, at least moderately. Maths though, you cannot have it as a weak point. So try to think like this, guys. So physics can definitely improve, and you will start seeing things which otherwise you are just looking at question. Do not look at physics like question answer, question solution. No, you should think much beyond that, like I told you. Okay, right. So let's do the next one. And in these questions, what do we need to exactly take care of? Definitely. Yeah. Okay. So I'll tell you what. First is, usually you should be knowing how the river or how the wind is blowing, how the river is flowing or how the wind is blowing. So maybe let's say the river or that wind is flowing or blowing in this particular direction. Chumma, I'm giving something. Okay, it could be a canal, maybe it is sea waves, maybe it is a river which is flowing, or maybe it is just a wind which is blowing in particular direction. Okay, so we will call it W. W is nothing but the velocity of the water, or basically the wind. So W for wind, W for water, anything you can think of. Okay. Now that aeroplane, that boat, that swimmer, whosoever it is, okay, it could be maybe that swimmer who is swimming, or it could be a boat which is going. Okay, it could be a boat which is going, or it could be just an aeroplane. Or it could be just an aeroplane, whatever it is. So you would know the next thing, which is basically U, which is velocity of the boat or the swimmer or the airplane or the bird, whatever it is. The last thing is the actual velocity which will be seen from the ground. Now, this U, which is the velocity of the boat, swimmer, airplane, bird, it's always relative to the water or the wind. This is very, very important, guys. Like for example, when I tell you, sir, can you swim? I'm like, yeah, I can swim. Sir, what is your swimming velocity, sir, or swimming speed? I am like, it is 7 kilometers per hour. Wow, that's great, sir. 7 kilometers per hour, you can swim. So what if the water itself starts moving? Then I do not know whether the water is moving or not. I will always swim thinking that the water is at rest, and I will use my strokes accordingly. So I will swim at 7, but if I'm going along with the stream, which is often called as the downstream, then if the stream speed is maybe 4 kilometers per hour, that 7 and 4 will get added and my speed will become 11 for a person standing on the banks of the river. But let's say I'm not knowing, I'm going against the flow of the river and I am putting my strokes 7 kilometers per hour and the river is going against me at 4 kilometers per hour. So 7 and 4 will subtract and I will be left with 3. So I will end up going at 3 kilometers per hour with respect to the bank. But no matter how the river goes, which direction it goes, I'm always trying to swim with respect to the river at 7 kilometers per hour. That is u, which is the velocity of the swimmer or the boat or the bird or the aeroplane as seen by the water or by the wind. So same thing, same thing you can say for the aeroplane also. Maybe sometimes there are strong winds, the aeroplane is going in a stormy weather, or maybe there is some cyclone or hurricane or whatever. So the aeroplane's engines will work with respect to the wind. So if the wind is pushing the aeroplane, it will gain more thrust. If it is against, then the aeroplane will go slowly. So the wind velocity definitely matters. Hi MD. So this u is always the velocity with respect to the water, relative velocity. So the final velocity which we get is the v bar, which is velocity of the boat or that swimmer or that plane or that bird with respect to the ground frame, with respect to the ground frame or with respect to the banks, with respect to the bank. And then this velocity obviously will be whatever is the river velocity, you take it and add it to the relative velocity. That's it. You will get the total velocity. Kind of makes sense because both components will get added to give me the resultant or the net effect of the river, and the person's strokes or the motor boat's engine will also have some effect. So both the effects combined will give me the net velocity. Make sense? Even if you do it via basic notation, you will still get the same thing. I'll tell you how. See, velocity of, let's say, the swimmer with respect to the ground frame will be velocity of the swimmer with respect to the water plus velocity of the water with respect to the ground. Now velocity of the swimmer with respect to the ground is v, this one. Velocity of the swimmer with respect to the water, this is this, which is basically u. And velocity of the water or the wind, which is generally given, it is always with respect to the ground only. So v is u plus w. You can even get it via chain rule. Look at it, it is chain rule. S is first, g is end, w is in between. S, w, g. We are using chain rule. Perfecto? Got it? Yeah? So this is the equation which you will have to use. Let's see if you can solve some questions. Say for example, you have a river. And the banks are basically, example, some 20 meters away, or let's say 100 meters away. Okay, 100 meters away. Now there is a swimmer or some boat over here, and this particular boat is going in a particular direction. Maybe first time the boat goes like this, and the second time the boat goes like this. It is mentioned to us that the river is flowing like this, maybe at 2 meters per second, example. 2 meters per second. The river is going like this. And also mentioned to us is the boat velocity in still water. In still water is 4 meters per second. Okay, same thing over here also. Let's say the boat velocity in still water is 4 meters per second. And this angle is also given to me. Example, let's say it is maybe, I'll take something like 30 degrees over here. And this time also, I'll take it 30 degrees like this. Okay. So the question is basically, how much time will you take to cross? How much time will you take to cross? How much will be the drift along the river? And how much will be the net speed that you will get? All the three questions. How much time will you take to cross the river? How much will be the drift along the banks of the river? And how much will be the net speed of that particular boat because of both the effects? Okay, so this is what we need to figure out. So let's do one by one, guys. Okay, let's do one by one and see what will be the answer. Let me make some space. So think, guys, if you want to find the net velocity, we need to take the boat or the swimmer's velocity and add it to the river velocity. River velocity already known, 2 meters per second in the x direction. This velocity can be split up into two components. That's kind of obvious now. So if I take this particular velocity and split it up into two components, one here and one here, can you guess how much they will be? Think logically. This is how much? 4, is it? So this is 4. This is 30. So base will be 4 cos 30. Cos 30 is root 3 by 2. So 2 cancels. So 2 root 3 meters per second. And height will be 4 sine 30. Sine 30 is half. So this will be just 2 meters per second. Okay. So that will be the river velocities components. 2 like this and 2 root 3 like this. 2 root 3 will be like this. And 2 will be like this. Okay. This has to be added to the water velocity. So water velocity is just over here. Just think about it. Water velocity is just over here. This is the velocity of water, which is W, which is 2 meters per second. The result will be like this. The result will be like this. Can you see that, everyone? This is your resultant velocity V. This is your resultant velocity V. Can we find that vector out? 100%. We can definitely find it out. If you can visualize a big triangle now, you'll have to visualize a big triangle now from here to here and here to here. Yeah. So can you guys quickly tell me what is the height of the triangle? The height of the triangle will be exactly this, which is nothing but 2 meters per second. Can you see that? That's the height of the triangle. Can you tell me the base of the triangle? Well, this is 2 and this is how much? 2 root 3. This is 2 root 3. This is 2. So the total will be 2 plus 2 root 3 meters per second. That is the total base of the triangle. So that's it. We can find now everything, whatever we want. For example, we want V. V will be root of, using Pythagoras, 2 square plus 2 is common over here, 2 into 1 plus root 3 square. Okay, so this will be nothing but 4 plus 4. 1 plus root 3 square means a plus b whole square. 1 plus 3 plus 2 root 3. That is what it will be. And therefore, this will be 4 plus 1 plus 3 is 4. 4 4s are 16 plus 4 2s are 8. 8 root 3. Okay. 4 plus 16 is 20 plus 8 root 3. So if you want, you can take 4 common outside. and this will be nothing but 5 plus 2 root 3. So 4 outside the root will become 2 root of 5 plus 2 root 3 meters per second. That is the speed. That is the net speed which the boat will go with. That is the net speed with which the boat will go. Is that right, everyone? Relative motion, this is the last class. Fair enough? Till this point, absolutely clear? How did we find the net speed? Okay. Now tell me, in order to cross the river, will I need the vertical components of velocity or will I need the horizontal components of velocity? Quickly tell me the answer. To find the time to reach the other side, will I need horizontal components or vertical components? Because when I cross, I just have to reach somewhere here. Doesn't matter here, 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 or here. Somewhere I have to reach here. So I have to just cross this line. If I have to cross this line, doesn't matter here or here, I'm only interested in the vertical components of the velocity. Does that make sense to all of you? Does that make sense to all of you? So in order to figure that bit out, I'll just say the time taken to cross will be the distance between the banks and the vertical component of the velocity. Distance is 100. What is the vertical component? This one. This over here, can you see? This over here is basically Vy. Velocity's vertical component, y component. So that's it, divided by 2, which means it will take 50 seconds for you to cross the river. 50 seconds to cross the river. Time is distance by speed. Yep. Good. Because horizontally, whatever your speed might be, how does it matter? To cross, I need this. I just have to cross that line. Doesn't matter here or there. I just need this speed. So that's it. Now, what is this drift, sir? See, the resultant velocity came out to be somewhere like this, isn't it? Somewhere over here. If you continue your journey along that path, you will reach here. Ideally, the direct opposite point is just this much. Ideally, the direct opposite point is just over here, but you ended up reaching over here. So, along the flow of the river, I drifted, I got carried away along with the flow of the river, starting from here to here. So, this entire distance that you see, the direct opposite point to this point, that is basically the drift that you encounter. Is this understood? What is the meaning of drift? If you drift along a river, means you got carried away by the river. How much did you get carried away by the river? So that is basically the drift. Now, think about it. Drift is nothing but a distance. So drift will be, distance will be speed into time, but which speed into which time? Will I take the river speed into time or will I take the net speed into time? Think carefully and answer in the chat box. If I have to go carried away by the river, not only will the river speed push me, but also when I'm going like this, a part of my velocity, which is the cost component in this case, is also pushing me along the river. So that is the result which I get, which is basically your Vx. So it is nothing but your Vx into the time taken to cross. It is Vx into the time taken to cross. The net velocity is horizontal component. Yeah, net velocity. So it will be 2 plus 2 root 3 multiplied by time taken to cross, which is basically 50. So 2 is common. So 50 into 2 is 100 and 1 plus, of course, root 3 meters per second. Sorry, just meters. So that is your drift, guys. That is your drift. Understood? Clear? 1 second, guys. 1 second, please. Yeah. Okay. Now let's go to the next part, which is this one. Where is it? Here. Very similar techniques. Very similar techniques. I will be little bit quick in this part now because things are just like before. It's just that it is in the opposite direction. Obviously, this 30 can be split into this this velocity of that river. Sorry, velocity of the boat, which is 4, can be split into 2 components. One component like this. The base component, how much was it? 2 root 3. So this will be nothing but 2 root 3 meters per second. And similarly, we can split it like this. This was 2 meters per second. Okay. So that is assuming this particular angle was 30 degrees. For that, you add the river velocity. River velocity is 2 meters per second. So that means it will be like this. So that is 2 meters per second. So the result, that is little tricky here, it is only this much, guys. The resultant is only this much. That is your resultant velocity. Now can you guess? There is a small triangle which can be made over here. Yep, there is a small triangle which can be made over here. There is a small triangle which can be made over here. Can you see? Over here, this is the base and this is the height, and this height is basically Vy, and this base which you see over here, this much part is basically Vx. Can you guess how much is Vx? Vx will be this entire thing minus this, because this total length was 2 root 3, this much was 2, so this will be 2 root 3 minus 2, and Vy is just going to be 2. Yeah, makes sense, everyone? Just 1 second. Perfect. So again, do the same thing. The time taken to cross will be the distance divided by the vertical speed. Distance is basically 100. Vertical speed is 2. So it will be 50 seconds. That's the time taken to cross. The resultant velocity is here. So that means you will end up going like this somewhere over here. And ideally, the direct opposite point would be here. Direct opposite point will be here. But you ended up drifting against the flow of the river. So this is my drift right now. I've drifted against the flow. Magnitude wise only we will find it out always. So drifted against the flow. How much will it be? Again, horizontal speed into the time taken to cross. What is the horizontal speed? That is nothing but 2 root 3 minus 2. Time taken to cross is 50. 2 common, 5 into 2, 10. That means 100 into root 3 minus 1 meters. So that is the drift in this scenario. Did you understand how to solve the riverboat questions? Are there any direct formulas? Is there something you have to remember? Nothing, right? Everything has to be logical. Everything has to be on the spot. The only thing which you will remember is who adds to give whom. V is U plus W. If you know that, everything is straightforward, and this is also very obvious or very, natural. It's not very unnatural that you have to think, oh, U is V plus W. Sir, I didn't remember that equation. It's very natural, man. Flow of the river and the boat's velocity together will give you the net velocity. Nothing like you have to, sir, I forgot what is the symbol. It's okay. You use donkey symbol. You use D bar. Okay. You use M bar, monkey, or you use anything. Doesn't matter. Symbol doesn't matter. If you know the concept, you can apply it. Okay. Now there are two special cases in this. One is crossing in the shortest time. Crossing in the shortest time. This is very interesting. Just think about it. For some reason, the water is maybe radioactive or something. Okay, there is a World War III or something, and you are in enemy territory or you are trying to save your life. And you know the water is radioactive, and that is the reason why you will spend minimum time in the water. And the water, because the dams have burst, World War III has broken out, the water is also flowing very fast. But fortunately, you have some survival skills, and that is the reason why you want to go to the other side, because you know this side something is going to happen. So you have to go to the other side. Maybe there is a pack of wolves or tigers who are chasing you. Anyways, so now you have multiple options to swim. Whether you swim like this, or 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 whether you swim like this, so that you reach onto the other side. Okay? Okay, so think, how are you going to save yourself by spending least amount of time in the water, because the water is radioactive, so you cannot spend more time, it will burn your body. Yeah, that is some high level thinking, isn't it? 1, 2, 3, 4, 5. 3 is perpendicular, 1 is almost against the current, 5 is with the current of the flow, current's flow, and 4 and 2 are somewhere in between, some suitable angle. Many people are saying 5, few people are saying 3, and equal number of people are saying 4. All right, Mohammed saying 3, Anto saying 4, Pranav saying 5, okay. Tejaswini saying 4, Harsh saying 3. Niraj, what about you? Okay. Third case, Sabri. All right, I'll tell you what. You guys felt it should be 4 or 5 because I'll tell you why. It's natural. Okay, river is flowing. Why not use the velocity? Why not use the velocity? My speed will be higher. See, we as human beings, we think, oh, river is going that way. If I swim like that, my speed will be higher. Very good thinking. Fine, your speed will be more. But what will you do with that speed is my question. You will just keep on moving, man, that side. There is no point going. What will you do? Keep it, okay, then go 5 only. No, you're going like this. What are you doing with high speed? You're just going in the river with very high speed. Nicely, your body will be covered with full radioactive material. You'll be spending more time and you're not even using any velocity to cross the river. Remember that the time taken to cross the river is the distance between the banks by Vy. If I want the time taken to cross to be minimum, Vy should be maximum. And the only way out of the two velocities, my Vy component will be only maximum in one particular scenario. Can you guess? If my V has to be maximum, that is only possible if I rotate this velocity and make that velocity like this. Then my entire velocity will be Vy, and that will be maximum, of course. Only then the denominator is maximum, the ratio is minimum, so time crossed is minimum. So definitely you will use this velocity. That means the velocity u should be perpendicular to the river's flow to cross in minimum time. To cross in minimum time. That is the logic behind it. Is this absolutely clear? Perpendicular one. So very obvious now. If you see mathematically, it is like, yeah, yes, sir. Oh, why did I not think about it? Yeah, the entire velocity when it is like this, I don't care what is the speed of the velocity of the river. Doesn't matter. I want to spend least amount of time. Sir, but the river will pull me there. Good, it's okay. What will you do? Okay, fine, you will reach here. But at least you are not in the river. The aim, the objective, target was not to reach on the opposite side or was not to have maximum speed, but it was to spend the least time. So I will not bother what the river is doing. I'll just move perpendicular to it. That is the answer. And then comes the next scenario when you want to cross it in the shortest time. Distance. You want to cross in shortest distance. Oh, by the way, this can be also used by aeroplanes or missiles. Maybe there is some enemy territory below and that missile has to go from here. There is a border over here. Some enemy border is there. And the missile has to go on to the other side and the wind is blowing. Very strong hurricane, something is coming. So, in that case, the missile will be fired like this. Yeah, but it will end up drifting. That's okay. But missile will spend very little time in the enemy territory or it will go on to the other side very quickly. Okay. Same now, crossing in the shortest distance means what? These are the banks. These are the banks. And you have to reach over here. Shortest distance. Shortest distance. So obviously now, you will try to swim like this so that even if the river pulls you like this, your net velocity will be in this direction. Your net velocity will be in this direction. That's how it should look like. Yeah. So in such a case, your drift will be 0. Your drift will be how much? 0. Understood, guys? Absolutely clear about this? Straightforward? Pakka? Shall we do a question on this then? Shall we do a question on this? Okay. Fair enough. Let's do that. 1 second. Here is the question. River speed. Maybe, I don't know, 4 meters per second. Boat speed. 5 meters per second. Distance between the banks of the river. Let's say 50 meters. First is shortest time and its drift. How much will it be? Second time, if you are going in the shortest distance, how much time will you take to cross and what angle with the flow will the boat point so that it crosses in the shortest distance. Okay, so let's solve one by one. The first scenario is shortest time and what is the drift encountered. Second is shortest distance. Okay, let's do both the cases, guys. Let's draw the diagram first. Okay, this is how much? 50 meters. Perfect. Great. So if you want to cross it via the shortest time, it's obvious now that my boat will be pointed like this and the speed of the boat will be 5 meters per second. It is okay that the river will pull me like this with a speed of 4 meters per second. So my resultant velocity will be like this. My resultant velocity will be like this. That's okay. And I will end up reaching somewhere over here. So this thing over here will be my drift. Okay. So diagram is at least clear. So first thing, how much time will you take to cross? Time taken to cross is distance divided by the vertical speed. Distance is 50. The vertical component is just 5. 50 by 5, that's 10 seconds. That's the time taken to cross. You cannot cross the river in less than 10 seconds, no matter what you do. Okay? No matter what you do, you cannot cross it less than 10. Next thing is the drift. Next thing is my drift. Drift is the horizontal speed, which is Vx multiplied by the time taken to cross. As you can see, the velocity's horizontal component is exactly 4. It is exactly 4 and time that I have taken is 10. So I will drift 40 meters. So from the direct opposite point, I will reach 40 meters ahead in the flow of the river. Cool? Pakka? This case clear? How to solve the questions on them? Very straightforward once you know the theory concept behind it. How about the next scenario where you have to cross it in the shortest distance? Okay, you have to cross it in the shortest distance. What is the time and what angle will you point the boat? So first of all, I will make my boat aligned like this, so that even when the river will pull me over here, my net resultant direction will be like this. Okay, so this is my V. This is 4 meters per second, and this is basically 5 meters per second. Perfect. So let's start figuring out things. Starting off with time taken to cross is distance divided by Vy. Distance is still 50. Okay, 50 meters divided by vertical speed. Guys, the vertical speed is V itself. The vertical speed is V itself. So how much is V? Well, Pythagoras we can use over here. It will be nothing but 5 square minus 4 square, which is 25 minus 16, which is the root of 9, which is 3 meters per second. So divided by 3. So time taken to cross is 50 by 3 seconds. 50 by 3 seconds. Sorted. Now, another question asked, by the way, drift is not there. Okay, so drift was not even asked here. The drift will be 0. You're reaching the opposite side. What angle will you make with the flow of the river? So I think we have to figure out what is this angle then. How much will this angle be? Theta. Can you guess? I think we can use sine theta. Sine theta will be opposite side by hypotenuse. So therefore, theta will be how much? 53 degrees, I believe. Sine of 53 is 4 by 5. Okay, perfect. But that is not the answer. Please understand that. So the angle which the boat makes with the flow of the river is, be careful, the boat is pointed here, but the river is flowing like this. So be careful, guys. This much angle is 53 degrees. This is 90 degrees. So technically, it should be 53 degrees plus 90 degrees, which is 143 degrees. That is the answer. Okay, lot of students will give the answer as 53. It will be there in the options, but you will get negative marks for that. The question was with the flow of the river. The river is flowing like this, and the boat will be pointing like this, will be pointing this way. Even though it is pointed like that, it will go like that, straight like that it will go, because the river is pulling it here. So that's how the motion will look like. Loved the question? These are the kind of river boat man questions which you will get. Okay, so we have done all varieties of questions. There will be more advanced questions. We'll have a problem solving session. Relative motion is such a topic where even if you solve 50 questions, you will still find always one question which you have not done. So practice a lot. Even rotational chapter, Newton's laws, circular motion, EMI, magnetism, electrostatics. These are such chapters where no matter, even if you solve 200 questions, always there is one new question which will come up. You never know. Okay, so we'll practice more. So this chapter is done as it is. So see you guys. Have a great time. Yeah, and I will keep meeting you for problem solving. Okay, bye bye, and keep working hard. Thank you.